Dr. Lei?
Oh, hi.
Yeah,
Oh,
can you hear me?
oh, hello. I'm
Can
sorry.
you hear me?
Yes. Can
Okay,
you
that's
hear me?
good. Yeah, would you please try to share your screen?
Okay.
Ngon rồi quá. Chị ủa vậy hả? Vậy là hãy nhắn tin cho em xin kia.
Chắc vậy.
Thế thì có báo không?
Dạ. Người này đang bị mất giọng cái ai nghe được.
我我叫我先开放，这是什么？要不然换一下，好，谢谢。
Trước đó. Lại chia ra. Cái hơn.
So, would you please open your slide and try to present 1 or 2 slides?
Yeah.
And we can.
Nấu nhiều không kêu được không đồ ăn. Không phải à?
好，信号，他不是用那一台，他是用他那一台。哎，我给信号，老师你信号，庄老师啊，哎，我坑这会，坑在一个。
Can you see the slide?
Would you please run it, play the slide?
Yeah.
It's kind of slow, right?
Oh yeah, maybe because of my laptop, it's a little bit
okay.
slow. Okay. Yeah.
Okay. Round to the very last one. It's done?
The last one?
Yeah. Round to the last one.
Yeah.
Okay.
Yeah, this one is the last one.
Oh, okay. Can you speak? Just try to present one slide.
Okay. So let's start from. Okay, so In this presentation, I would like to present to share one of my work about antibiotic resistance in Saigon River in Ho Chi Minh City. So this slide will show the antibiotic resistance. So many scientists predict that this will be the next pandemic in the coming future. So there are many.
Okay, it's good. It's good.
Okay. Okay. Thank you.
Yeah, we can hear it clearly. No problem.
Yeah.
Okay, then that's it. Okay. You are in the second session, right? Are you in the second section or the last one? Last session?
Last section. I
The
still
last
remember
one.
the last
Okay.
one.
Okay. Okay, good. I think it's good.
Yeah. Thank you.
Okay, thank you very much.
Yeah.
And Professor Hugh,
Hey.
can you hear me? Oh, yes, that's
Yes.
good. Okay,
Yes.
good.
Good afternoon. Yeah, we're testing the connection. So can you hear me?
Yes, yes.
Yeah,
But kind of
that's great.
the sound, the volume kind of small.
Really? I'm sorry.
Yes.
It's maybe one of the reason is because my voice not in the good condition.
Okay, now it's better. It's getting better.
I will try to speak up.
Okay. Can
Yeah,
you share
but-
your screen?
Yeah, of course. Wait me a moment. Okay. I think the other should turn off the sharing screen. I can't send it now because maybe the previous person is still in the sharing mode. He need to turn off sharing the screen. So that's what I will do it later, the next.
Okay.
Yeah. Yeah.
Đúng không? Em nói thì chút xong rồi vô kia cô xếp thành một. Ủa xếp thành khác nhau à? Cô và xếp thành một. Em cùng chết chưa? Đã xong chưa? Vô rồi hả?
Yeah, I can see your screen. Can you open your slides?
Yes.
Okay.
Can you see my slides?
No.
Wait for me a moment.
Underneath there is a share screen button.
Yeah, I chose it already, but it say I cannot start screen share while the other participant is
Okay, wait a
sharing.
minute. 我们有限制他 share screen 吗？不会吧？不会哈。Yeah, can you open your slides?
Yeah. It still say I cannot.
We cannot see your slides yet.
Yes. Can you see? I will show my slide here.
No, it's only like an empty screen.
Wait a moment. So can you see it now? I think, excuse me, can you hear me? I think I found on the list of participants, the participant Lê Thái Hoàng is still in sharing screen.
Yeah.
So that's,
I
think he
他为什么没办法上来？
I think he should
他的
stop
screen 啊，
it.
他的 slides 啊，把分享关掉。Wait a minute, wait a minute， 你有关掉它？
Yeah, it's okay. I think I can say it now.
Can you try them one more time?
Yeah. Yes, yes. I think it's okay now.
Okay, that's good. That's good. That's a mistake by our engineer.
Yeah, yes, I guess
Okay,
so.
okay.
But it's okay.
Can you
It's no problem.
try to present it?
Okay. So can you see my slides now?
Okay, okay.
Yeah. So I just okay. I try to present
so
a
would you
bit.
please just try to present one slide?
Okay. Okay. I would like to present my topic about assessments of drugs and personal care products.
Your volume is really small. I cannot hear you. Sorry.
I'm sorry, because my voice not in a good condition now.
Okay, it's much better.
Yeah.
Maybe you have to hold your mic.
Okay. I don't know where's my. It's fine. Today I would like to present my topic is about assessments of drugs and personal care products.
That's good.
Okay.
Yeah, that's good. So could you just run your slide to the very end of it?
Okay, sure. So I go one by one. It's very quick. Is this okay? Yeah.
The last one.
Yeah. This is the last one.
Thank you. Is the last one. Okay.
Yes. Yeah.
Okay. Good. That should be good.
Yeah. Thank you.
Okay. Thank you.
Thank you.
So you know the time and which section it is, right?
Yeah.
Okay.
Yeah.
That's good. That's good.
Good.
Then I will see you then.
Yeah. See you then.
Okay. See you.
Thank you.
Thank you.
Bye. Yeah. Dạ em mới test thử.
Test gì ông xong rồi?
Dạ.
Chắc là mình với sẽ phải cùng session.
Dạ. Dạ thêm mượn trước đúng không ạ? Dạ.
Bây giờ xài luôn cái dung của ông
cái cầm tay đây.
Cái tay ngay ngọn được, mấy ngọn được. Để là ngoài cũng được.
Đây là
mấy có là ngoài không?
Em cũng có sao? Nhưng phải có đầu nối không ta? À đây hả? Để tai nghe.
Đúng rồi. Ok.
Excuse me, are you also a presenter this afternoon?
Máy này không có là ngoài.
Có. Nãy nó mới nghe mà.
Okay.
Có vừa nghe bật to.
Good afternoon, Professor Suji.
Oh yes. You're one
My
of
name
the presenters.
My name is Thành. So now I am in the office with Dr. Huệ. So I will use the computer with Miss Dr. Huệ to present.
So please accept. I couldn't join.
Hello.
Hello. Please.
Professor Hin. So I don't know who this presenter is. Could you point me to the name?
Yes.
So sorry, I cannot hear you. Sorry, what's your name?
Thành.
My name Thành.
He's already tested last week.
Oh, okay. Tan.
You say me?
Tan.
Yeah,
That's right. Sorry, I memory is really bad.
No problem. So
you're the first presenter of the second session. Is that right?
yeah, that's right.
Okay, good. So you will share the connection with Professor Hin.
Yes.
Yeah.
Oh, good. That's good.
Dr. Huệ.
Yeah.
Yeah.
Do you want to run your slides again?
No. Oh, yeah. The file Okay. I will send to you soon. Yeah.
Okay. See you then.
So please accept my Professor Suji. Professor Suji. So please accept. I couldn't join.
Yes.
So please accept my account. I couldn't join.
我还在用，你可以寄给他吗？可以寄给他吗？
Gõ cái gì đó. Gõ chat. Có chat cái này gõ đây nè. Nhưng có chat này. Ok.
胡志明市的理科大学，对，理科大学，对。对。
1 hour later. Wait. Copy cái file này vô trên máy của em đi. Cái này đâu sợ bị rơi virus đúng không?
Này có file em chỉ gửi qua email.
Gửi email luôn đi.
Dạ.
Em là gì?
NTT về không hết xem bỏ. Em đào về. NTT về.
Không phải. NTT.
Dạ, 2 cái T.
Sao mà cái nó vô em thì em đa số sao nó không.
Ủa, coi YouTube thấy chưa? Cái đó mình được vô Zoom đi hả? Ừ. Dạ. Em không có vô.
Cái gì đó mà được nhá.
Em không có vô. Có ông làm viên 2.5 dùng cái gì đó? Đó. Tí mà cứ nghe đi. sinh đầu toàn khí mà. Sao không cho cô vô ta? Em đừng có ao ra nha, em nằm trống luôn đi.
Em nằm đó luôn, em nóng ra.
Em vô coi gửi ổng ra xét được chưa?
Chưa thấy tên cô. Chắc ông đang bận nhiều cô ơi.
Rồi nè.
test 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 test。那个直播可以看得到吗？直播可以哈。那个我们有在网络上直播，所以他们的学生都可以从 YouTube 直接看。所以那个 banner 可以出来吗？时间到了。 Okay, it's about time for the opening. Professor Hin, can you hear me? 可不可以先跳？先跳出来，这个先拿掉。Okay. Professor Hin, can you hear me? No? 你把他的声音打开好吗 ？Professor Hin, H-I-E-N。对 ，H-I-E-N。从他那里开不就可以了吗 ？Can you hear me? Professor Hin?
Yes.
Cô Hiền nói không nghe. Cô Hiền tắt mốt rồi.
Hin. H-I-E-N 全部先解开好不好？全部先解开。
Okay, it's okay now.
Okay, good. Okay. Professor Hin and the presenters in Vietnam, welcome to the webinar 2021 hosted by the National Chongqing University. You are very welcome to join it. And now I will introduce our Vice President of the Office of International Affairs, Professor Shi Hang Yang. Yeah, and he will give you a very short welcome remarks.
Yeah.
Thank you. Hello, everyone here, and also we have our dean, College of Engineering, Professor Wang. Thank you for Chairman Professor Chen invitation. We got a chance to show you about this host this webinar conference. Okay, I represent on behalf of the Office of International Affairs. It's nice to hear to go through to see you online. Anyway, for NCHU, some facts I want to say is about right now. National Chongqing University have about 800 students from overseas, and one of the largest group, the student from Vietnam is the number one. Totally, we got about 60 students from Vietnam. So Vietnam is a very important international student resource. And right now, NCHU continue go for internationalization. We provide some scholarship and also continue with research fund, cooperate with other countries. And Vietnam is our neighbor country. It's very close to us. In particular, we have a direct flight from Taichung to Ho Chi Minh City. It's about 3.5 hours. So it's a very short distance. We hope about if two countries can continue for interaction, we hope we got a chance to visit both sides. And due to COVID-19 issues, but I think it will pass away very soon. And my final word is about hope everyone keep a good health and continue for our research. In future, we can establish more cooperation work on this field, particular for environmental and also other engineering. And thank you very much. Okay. We'll give a applause to Professor Yang. Okay. Okay. Now we welcome the Dean of our College of Engineering, Professor Guo Zhen Wang, and he will also give a short speech.
Yeah, I hope you can see me right there. Well, it's because the Vietnam and Taiwan are good students in the epidemic protection. So we got a chance to have the chance here. So we don't have to be in somewhere at home, and still we can come here to celebrate the or share our research in sustainable feature. So it's really great. Actually, I have a student from Professor Hugh and just went back to Vietnam to change the visa, and then she will come back later. So I think we, because both the university are good sister university, or we are good, very good friends. So the science university of the Ho Chi Minh City. Actually, it's our best friends in Vietnam. So hopefully, not only this time, this is just beginning. We hope in the future, or just probably in August, we can have chance to meet with each other because we perform very good in the epidemic protection. So hopefully, so we can meet each other, whether or maybe in Taiwan or in Vietnam. So we can stand together and then discuss the future collaboration in research. Not only in the sustainable feature, but also in other areas, especially for the College of Engineer and also your university. We can work together, and then we welcome more students come here because actually, for foreigner students came to our university, it's tuition free, at least for the couple years. So we hope we can have more students come here, and also we can have our young faculty to visit your university and to work together for the future. Yeah, and I hope the conference goes well, and then we meet each other in person quickly. Okay, thank you.
Okay, thank you. Okay, thank you, Professor Wang. Now, we will ask Professor Hin. She's the Dean of the Vietnam National University at Ho Chi Minh City and University of Science. She's the Dean right now, and we'll ask Dean Hin to give a short welcome speech from Vietnam side. Are you ready?
Yes, thank
Okay.
you for your introduction. So good afternoon, everyone. And first of all, I would like to thank Vice President Professor Yang, Dean Professor Wang, and also Professor Su Chi Chang for planning for the webinar today. I think that this is the first scientific activity between two universities since we signed the MOU last year. And I hope that after this webinar, our collaboration will be more developed between your university and my university. I hope that we will have more exchange students, more Vietnamese students go there for study master and also PhD course, and also more co-author in the publication. And we also willing to accept all of the students in Taiwan go to Vietnam for the short time to have the environmental problem in Vietnam, and together conduct the research in the environment in Vietnam. So I hope that our webinar will be successful, and we will have the strong collaboration later. So thank you so much.
Okay, thank you, Professor Hin. Give big applause. Okay. Okay, thank you. So now we'll start the first session of this webinar. Actually, the first session is chaired by Professor Hin. Okay, so I'll give the time over to Professor Hin.
Yeah, so thank you very much. So now I would like to start the first session in our the session about the air pollution control and energy. In our session, we have the 4 speakers, and every speaker have only 15 minutes for presentation and also for question and answer. And first of all, I would like to provide Professor Hyu-Sin Sen from Advanced Membrane Material for Sustainable Environment Lab, Department of Occupational Safety and Health, Chung-Sang Medical University, with the presentation reason process in the carbon membranes for gas separation and emulsion purification. So, Professor Hyu-Sin Sen, please.
Good afternoon, ladies and gentlemen. Pinker Victor Cavacho Vicanini. Good afternoon, ladies and gentlemen. Pinker Vinling Cavacho Vicanini. Thank you for attending the VNTW Taiwan's webinar series on research for sustainable future. I'm Hui Xinzhen from Zhongshan Medical University, and you can call me Anna. And I'm very happy to be here with you today.
Thành ơi, em có thấy được khuôn mặt mình không? Hả?
Okay. Before start my presentation, I would like to
excuse me.
the research.
Excuse me, we couldn't see the full screen of your presentation.
Okay.
Yeah.
Okay.
Okay.
Okay, now I will start my presentation.
Yeah,
Can you
okay,
hear
it's
me?
okay now.
Okay, thank you. Before start my presentation, I would like to introduce the research topic in our laboratory. That's including the carbon capture, clean energy production, and the resource recycling and the wastewater treatment, which are based on the membrane separation technology. So in our laboratory, we focus on how to design and how to synthesize the membrane material and apply it for green and circular process for sustainable environment. So in today's report, I will briefly introduce the research achievement in the air pollution control and clean energy production. And I will focus on the carbon-based membrane and the water-based membrane. So how does membrane separation technology can assist the carbon capture and the clean energy production? So here shows the IGCC system. This system has been widely investigated and applied for the hydrogen energy production. So from this figure, we can see in here, we can use the coal or the biomass as the resource. So in the gasification at high temperature or high pressure, the syngas will contain 25 to 45% hydrogen. And then we can add gas into the stream to let it react with the carbon monoxide. So the hydrogen concentration can be increased to 35 or to the 65% or more than 65%. So if we want to produce the high purity hydrogen energy, then we can use the membrane to separate those two gases. Okay, so how do we can separate one of the product? So from this table, we can see the property of the final product. So when we compare with the carbon dioxide, we can see the hydrogen has the smaller kinetic diameter. Its kinetic diameter is only 2.8. And hydrogen also has the low critical temperature. So based on the solubility and the diffusion coefficients, we can use the membrane separation technology to separate hydrogen from the carbon dioxide. Okay, so here we can choose the porous membrane. So if we choose the porous membrane, the gas with the smaller kinetic diameter will pass through the pore very quickly. And we also can choose the dense membrane. So if the gas with the low critical temperature, it will solubate into the membrane and transfer through the membrane very quickly. So in our laboratory, we prepared many kinds of membrane. From 2004, we prepared the carbon membrane. The carbon membrane is one kind of inorganic membrane with porous structure. So that's why it has been recognized as a potential membrane for the carbon capture. But the carbon membrane is braidless, so it's not very easy to prepare. And we also prepare the polymer membrane and add many kinds of nanomaterial like the CNT, SBA 15 or MOP into the polymer matrix to modify its structure. And we also cooperate with the Czech Republic, and we come some interesting ideas to use the water as the membrane material. And now we also focus on the organosilica membrane and the ion liquid membrane. So today I will focus on the carbon membrane and the liquid bubble membrane. The first one is CMS membrane. So here I show you the image of the carbon membrane. So from here we can see the carbon membrane has the black colors. And in order to enhance its mechanical strength, carbon membrane usually prepare as the supported type. That means we need to use the aluminum substrate or others inorganic material as the substrate. So here is our new find. We find the CMS membrane structure with the TN and the FIB technique to measure the D-spacing of the carbon membrane. So from this figure, we can see that D-spacing means the diameter of the pore size of the carbon membrane. So if we want to use the carbon membrane for gas separation, the D-spacing must close to the kinetic diameter of the gas, like for hydrogen. Here, the D-spacing is close to 2.6 angstrom. So how to adjust or how to control the pore size of the carbon membrane? Here shows the typically 6 steps. For the step 1, we need to choose a suitable precursor like the PI. And the second step, we need to prepare the polymer membrane, and it depends on which kind of construction you need. And the third step is pre-treatment to solve the polymer chain. And the fourth step is pyrolysis at high temperature. So for the fourth step is a critical step to control the pore size. And the final, you can use different pre-treatment to modify the pore structure. So after pyrolysis, the CMS membrane will process the bimodal pore size distribution. For the large pore, maybe if you are large more than 6 angstrom, and it can provide high permeability. And for the smaller pore, it should be close to which kind of gas you want to separate. So the small pore usually smaller than 4 or smaller than 3 angstrom, and it can provide high selectivity. So here, if we want to separate hydrogen from the carbon dioxide, that means the smaller pore should be close to the dimension of 3 angstrom. Okay, so our laboratory start to prepare the carbon membrane in 2004, but at the beginning we cannot get the product. We cannot get the brake membrane because it's not very easy to control the vacuum system. So my students are afraid to be assigned to take part in this research subject. So eventually we got the brake carbon membrane after 3 years. So from then on, we try to investigate the effect of the precursor and the pyrolysis protocol. And we also add many kinds of nanomaterial like the CNT, SPA15, and the MOF to modify the pore structure of the CMS membrane. And we also discuss how to use different kinds of pore treatment to modify the pore size. And finally, we found the critical issue to obtain a good separation performance, the carbon membrane, is depend on the quality of the substrate. So we try to add interlayer to modify the substrate surface roughness and its pore size distribution. And here I will give you some example. The first one is we use the MFI zeolite as the intermediate layer to achieve to improve the adhesion between the two layers. And another example is we use the titanium gel to modify the surface roughness to decrease the surface roughness and also to decrease the pore size. And then we use the simulation modeling to calculate the sufficient free energy. We found that the titanium gel can shows low free energy. So that's why it can improve the adhesion between the aluminum substrate. So here I will show some conclusion. So if we want to prepare the carbon membrane for hydrogen separation, the support substrate, the support structure is very important. So now we also try to synthesize different kind of carbon membrane, including the tubular type and the hollow fiber. And here I will show you the freestanding hollow fiber. So from the video, you can see the hollow fiber can be bent without any support. Okay. And the last one is about the liquid bubble membrane. The liquid bubble membrane is we use the water as the membrane material because it showed good solubility and the diffusion coefficient to the hydrogen and the CO2, the gas. So here is the, I show you the readout. So here is the equipment. From this equipment, we can produce the liquid bubble. So for the higher solubility gas like CO2, it will penetrate through the bubble, and the CO2 will maintain in the bubble and collected downstream. So we can use this equipment to separate the methane from the CO2. So this equipment was developed together with the Royal Academic. Okay, so that's our research introduction. Thank you.
Oh, and thank you very much for your presentation. So it turns to the question and answer. Do you have any question? So I have one question for you. I have asked in the membranes you use the substrate, for example, aluminum substrate or zeolite substrate. So have you ever used the natural substrate, like for example, natural zeolite, or just use the chemical?
Sorry, we use the aluminum as the substrate, and the zeolite is the intermediate layer.
So I mean, have you ever tried to use the zeolite or aluminum from the natural material? For example, from the waste, solid waste contain the aluminum or zeolite?
We use the chemical from the not from the nature, but from the chemical material, and then we use the sodium macer to prepare the silica acid.
Yeah.
Yes.
Thank you so much.
Thank you.
Excuse me, may I have one question?
Okay, please.
My name is Lê Tử Thành. Thank you very much for your very interesting topic. So I have one question.
Yes.
For selectivity factor, CO2 to hydrogen in the result around 18. So this factor is not so high. How can you control your membrane to increase the selectivity factor?
Would you please rephrase your question one more time?
Okay. Can you hear me? Hear me?
Yes.
Yes. In your result, your present selectivity factor around CO2 to hydrogen around 18. So in my opinion, this factor is not so high. So how can you make the membrane to increase the ratio, selectivity ratio? Thank you.
Selectivity, yes. We measure the permeability for every the pure gas, and then the selectivity was divided by both of two permeability. Oh, okay. Okay, so you asked how to improve the permeability of the hydrogen and the carbon dioxide.
Yeah, that's right.
Okay, we improve the permeability of the hydrogen, not both of them. So we adjust the pore size distribution to increase the porosity, but shorten the pore size. So only the permeability of the hydrogen can be increased.
Okay. So the secret is that the pore size, if the pore size is small enough, you probably only hydrogen can go through.
Yeah.
Is that good?
Okay. Thank you.
Okay.
So thank you very much. So do you have maybe for one more question? So maybe the time is limited. Maybe we, I would like to thank you very much, Professor Shen. And now we move to the next speaker. Okay. Thank you so much.
Thank you.
So it's my turn. So now so maybe you know me, I'm from University of Science, Vietnam National University, Ho Chi Minh City. So today I would like to share with you our result on the trace metal and volatile organic compound in two big cities, Vietnam. So so you know that the air pollution has been derived by the WHO as the largest environmental health risk that interview 7 million deaths global per year as a result of exposure of air pollution. And Vietnam is thought to be one of the polluted countries with around 16,000 deaths per year related to the air pollution. And in Vietnam, Hanoi and Ho Chi Minh City were the most popular city and have increasing global attention because of their poor air pollution status. However, the research on the chemical composition of air pollutant are limited, especially the soluble trace metal in the pi particle and the VOC. And now no comprehensive study of VOC has been conducted in Vietnam to date. So this figure show you the pi particle of inhalation of trace metal out to the pi particle may cause adverse health effect on the human health, especially when the metal are in the soluble fraction. And for the VOC, VOC refers to several groups of hydrocarbon, for example, non-metal hydrocarbon and oxygenated hydrocarbon. And VOC are emitted into the atmosphere, both androgenic sources and biogenic sources. So their reaction in the atmosphere will produce two secondary organic aerosol and also the other pollutant that affect on the climate change and also the human health. Therefore, in this study, we focus on the soluble trace metal in the 5 particle and also VOC in Ho Chi Minh City and in Hanoi. To know the characteristics of the soluble trace metal in 5 PM and for the VOC. So this is the sample size in Ho Chi Minh City. The 5 particle and the VOC was collected at the 2 sites in Ho Chi Minh City and 3 sites in Ho Chi Minh City and 2 sites in Hanoi. There is the one urban site in the center of the city, and the other side is the outside of the city. And for the center side in Hanoi and Ho Chi Minh City, VOC was online measurement. And this is the equipment for collecting the BM2. We focus on the 15 trace metal. You can see this is the 15 trace metal in the BM2. And after collecting the BM2, the soluble trace metal was analyzing in the laboratory at the University of East Anglia, UK. And for the VOC, we measure the 41 VOC online using the BTRMS and GCFAD equipment. And this is the list of the VOC was measured in our study. And these are some results. So we analyzed about 15 trace metal in the BM2.5. However, thorium was below the detection limit in the ensemble. And zinc is the most abundant metal in the BM2.5 at the both city. And in Ho Chi Minh City, the zinc concentration around 119 nanogram per cubic meter. And in Hanoi, the concentration of zinc is higher, about 450 nanogram per cubic meter. And for the cobalt has the lowest concentration in the BM2.5. And we found that the most trace metal concentration in Hanoi was higher than in Ho Chi Minh City. You can see this is the list arsenic and chromium. The concentration in Hanoi is higher than in Ho Chi Minh City, especially the toxic metal like lead, cadmium, chrome, and arsenic. And And in this work, we found that the vanadium and nickel, have concentration higher in Ho Chi Minh City than in Hanoi. Very high concentration of the vanadium and nickel in Ho Chi Minh City. This is very special in this study. This is a new found in our study about the trace metal in the BM, in the fine particle. And we try to identify the potential sources of trace metal using some methods. In this method, we use the methods that we use the diagnostic ratio and also the backward trajectory and concentrate wave trajectory. That means CWT, to know the potential sources of trace metal. And we found that the results show that all metal except vanadium and nickel has the highest CWT from eastern of North Vietnam and a part of China. So the eastern of the North of Vietnam has many industrial zones with the ferrous and zinc industrial, cement production and seaport activity. So additional the coal power plant with high capacity concentration of this area. So these sources significant contribute to the trace metal concentration in fine particle in Hanoi. And for the vanadium and nickel, we use the diagnostic ratio to know, to estimate the sources of them. According to the Berkeley research, if the ratio of vanadium and nickel range about 2.3 to 4.5, that means the shipping activity will be the main contribution of the BM, of the vanadium and nickel in the BM 2.5. And in this study, we found that the ratio of vanadium and nickel in Ho Chi Minh City larger than 3.3, and in Hanoi side about 2.5. So that's in line that the source of vanadium and nickel in Ho Chi Minh City is mainly influenced by the shipping activity. And also we using the hybrid backward trajectory of the soluble presence of vanadium, and the results show that all of the sources of vanadium move from the sea to Ho Chi Minh City and also in Hanoi. But effective of the shipping activity in Ho Chi Minh City is larger than in Hanoi. And for the VOC, this is the time series of the hourly emission ratio of the VOC, and we divide VOC to 5 categories, include alkene, aromatic, or VOC, and acetylene. And in Ho Chi Minh City, the average emission ratio of total VOC in the rainy cam band is higher than in the dry cam band. And in Hanoi, the total VOC is about 80 ppb, and hourly mean emission ratio about 12 ppb. And this is the temporal variation of the VOC. In Ho Chi Minh City, the hourly emission ratio in the rainy season about 8 to 350, and in the dry season is lower than in Ho Chi Minh City. And in general, in the rainy season, the VOC group was around double compared to in the dry season. And this result indicates that the seasonal variation of VOC species is very strong. And in comparison to Ho Chi Minh City, during the same period, March 2019, the total VOC in Hanoi was about twice as high as in Ho Chi Minh City. Clearly, VOC pollution in Hanoi was more severe at this time of the year. And this is the percentage distribution of the VOC group. You can see the alkane is the high concentration compared to the other group. And also to get more insight into the effect of traffic emission on the measure VOC concentration, the data were analyzed for possible weekend effect. You can see the low admission ratio were clearly observed during the weekend, and at the weekend, the morning peak was less pronounced, and bearing time is also so late. So the result further indicate that the observed missing the ratio of VOC in Vietnam are strongly affected by the vehicular emission. And this figure show you the effect of the transportation emission effect on the VOC in Vietnam. You can see this is the number of the vehicle, the number of the transportation in Ho Chi Minh City. We have the two big in the morning and in the evening. That's the rush hour in Vietnam. And you can see that the acetylene and ethylene is the primary pollutant. That means it's emitted directly from the sources. And the diurnal variation of acetylene and ethylene, the same of the variation of amount of the vehicle on the road. That means the VOC in Ho Chi Minh City, VOC in Ho Chi Minh City is strongly impacted by the vehicular emission in Ho Chi Minh City. And so I would like to withdraw some conclusion. So this study is the first evaluation of concentration of the soluble trace metal in the 5BM in Vietnam. And also this is the intensive online measurement of the wide range of VOC species, including 33 VOC. And this is the first time in Vietnam we have the data of the VOC, especially the OVOC in Vietnam. And from this result, we also have the characteristics of soluble metal in 5BM and also VOC in Ho Chi Minh City and Hanoi. And this research, this presentation is a part of our collaboration with some collaborators in UK. And I would like to thank you, the NACOSTAT and also Research Council of the United Kingdom for supporting this study. So thank you very much for your listening. The time for my talk is about 13 minutes. So that means we have the 2 minutes for question.
Hello, Hyun.
Yeah.
This is Ben. Yeah, this is very complete research and very impressive. Yeah, for all your equipment and also the sample and the model analysis. It's really complete. And just one small question: how much are you confident with your source identification? You say the most trace metal from Hanoi was from power plants, but VOC from Ho Chi Minh City from like local traffic. How much are you confident with this result?
At this time, I couldn't tell how much, but when we use the modeling and also the diagnostic ratio to estimate the sources of the trace metal, we just found that for the vanadium and nickel, it's very special trace metal in Ho Chi Minh City. It's affected by the shipping activity. But in Hanoi, for the vanadium and nickel, it's the effect of the shipping activity is lower than in Ho Chi Minh City. And we try to know how is the sources of another trace metal. And we found that in Hanoi, there are many coal power plants along from the north to the near to Hanoi. I think more than 20, I don't remember exactly, but more than 20 coal power plant in the north.
Also then from China, or it's from?
And some, and from the modeling, also some emission from China. Yeah, not only in Vietnam. Yeah, but in this study, we could not give you the percentage of the contribution, but in another, that means in another, that means now we have a lot of data. That means we have to calculate the distribution of the sources. When we use the not only the tray metal but also the soluble iron and the other organic compound, and we calculate together, and we will know more exactly about the distribution, the contribution of the sources of tray metal and also the other compounds. Yeah.
Yeah, can I have one more question?
Yeah, thank you.
Do you, in Vietnam, do you build up some like emission inventory for your country?
Oh, could you repeat?
Emission inventory, for example, how much emission, how many emission from the car and from the your factories?
Okay, so now we just have the contribution of the each sector by calculate in the using the material consumption. We don't have the data by measurement. That means we also calculate some emission inventory, but just calculation from the using material. Yeah. So that means in the Vietnam we have many. We will have many work to do. Especially we have to calculate the emission of the PM2.5, especially the primary contribution and also secondary contribution of PM2.5 in Vietnam, and also the other compound. Yeah.
Yeah, thank you, Kieran.
Yeah. So thank you very much for your question. So, do you have any question? So maybe the time is more than 15 minutes. So I have to move to another speaker. I would like to invite Professor Ben Doan with the title Quantification on the Source and Receptor Relationship of PM2.5 by a Gaussian Flume Trajectory Mode. So Professor Ben Doan, please.
Thank you, Kieran. Yeah, actually this work is, we have been working on this model for 20 years. So in our lab, we developed a Gaussian model. It's a trajectory model, very similar to high speed, we just used it. But we have more advanced feature. We can quantify the source portion. Okay, this is some paper published 20 years ago. So based on this publication, so build a model.
So excuse me, the sound is not clear, so we couldn't follow.
Yeah. Okay. Oh, sorry, I didn't use microphone. Okay. Can you hear me?
Yes, it's okay now.
Okay. So we just okay, we built a like Gaussian model like about 20 years ago, but this model has some strengths. We can do the source apportionment. So this is its strength for PM2.5 and its secondary PM2 as well. And this paper we published about 20 years ago. So based on this theory, we built this GTX model. And the idea for this Gaussian model, the conventional Gaussian model is just like the showing on the plot. It's like just everything is straight, and they cannot deal with the secondary pollutant. But we modified the Gaussian model. For example, right now its plume can be follow the wind. So it kind of trajectory. For example, we have Ho Chi Minh City or Taipei or Taichung. And here, then we can do the back trajectory. And if passing some, for example, power plant, then we know how much power plant is contribute its a portion to Taichung, for example. And we can pass some small stacks and automobile as well. So now the Gaussian formula is very similar to original Gaussian formula, but in the X, we change to T. It means the back trajectory time. So we just everything follow from the source, then we from the receptor we go back like time step by time step. And in addition, for quantify the secondary pollutant, we have this spatial term we call the mass fraction. For example, if you emit some SO2, this primary pollutant, but it can change to the form of secondary pollutant, for example, sulfur aerosol. So each time step, we just try to quantify how much SO2 is converted to sulfate and use this fraction term. Okay. And this fraction term actually is a function of production term. For example, SO2, the production rate of sulfate from SO2. Then when it converted sulfate aerosol, then they can be removed due to we call the, for example, the scavenge coefficient. The rainfall will take it down, and also the dry deposition will take it down to the ground. So use this form, we can do the we call the mass fraction in each grid. So then also we do some other changes. So right now the model can is much better than conventional Gaussian model. And just give you some idea how, can you click this? Should I? Okay. Sorry. Okay, we have to go to my web. Make a link. Yeah. Yeah. It's a link. Oh yeah. You see? Okay. Oh, can't do it. Should be go to your web. Oh yeah, here. No, it's this one. The second. Okay, sorry. Oh yeah, okay. So right now this is the well, you can see. Okay, yeah. For example, this is this is drawing by the CMAC model. In addition, you can see over here, this Taiwan, and you can see each like have a lot of red sign here, and this red sign means some station in Taiwan. So we do this prediction and also the analyzing. And for example, you can see this the wind is going to the northeast wind. So right now, on the downwind of Taiwan, we have the highest concentration in Kaohsiung. Can you also click? Can you have a mouse? Maybe I can use your mouse. Can I? Sorry. Okay. So each time I click each station, then they will do some analyzing. For example, we can do the source apportionment for this Pingtung station. And the red line here is observation, and this also color bar is we say the source apportionment. For example, the Pingtung station, and this green one is from Zhonggang, and the blue one is from the diesel car, and also from the fugitive, and the yellow one is from kind of boundary condition. So, and also we can check some back trajectory, and this showing you so for Pingtung we do the back trajectory. Now it was showing you how the wind going into this Pingtung station.
So excuse me, we couldn't see your screen.
Oh, you can't see my screen?
Yes.
Can you? Because, down, okay. But anyway, this just should give you some idea how the model is.
Okay.
Is running. Okay. Need to wait your PowerPoint. Okay, let's go back to my PowerPoint. It'll be easier. Okay. Okay. Yeah. Okay. Click here. Okay. So now you can see how this this is one resolution, 1 kilometer resolution of mesoscale model. We use about 3,000 core from the NCHC, our supercomputing center. So we can count this wind field. And you can see this, we call it AD. And this AD they will change the pollutant concentration, the map. So you can see when have some backward AD, so the pollutant going up. And so during the night, had concentration going into Taipei. But after a few hours, this wind is going to change. So they blow the pollutant downwind again. So like every day we do this simulation every day. Okay, so just some idea showing on the November 18 last year. Okay, this observation map. And this is the model simulation by our GTX model. And this is another famous model called CMAC. I think this is the most popular model. So you can see, you can compare this observation and simulation by the two models. Actually, the model developed in my lab is not too bad. We can see the high concentration in Taichung. And you going down this Zhongmin station, that's in Taichung station. So we can do the source apportionment. For example, on November 18, in Zhongmin is more than about 35, and 35 is our national standard. And we do the source apportionment and say, oh, the yellow one is from upwind area, and the blue one is from diesel trucks, and also another blue one is from Taichung power plants, and some also from some small boilers, and the green one is fugitive. So every day we do this simulation and we provide this one on the web. So everybody on the web, they can see, like we do the 4-day forecasting and we telling you, and after 4 days, and what will happen to our air quality and where's the source will come from. So then the administration, they can check, for example, if you see the Zhongmin station, for example, we do the back trajectory, we see, oh, it passes in some power plants. So maybe if you try to reduce this hazard, you should ask Taichung plant to lower down their emission. And some from like it's a petroleum company, and also from the Sinda power plants. And this many green one, blue one here is from diesel trucks. So actually you can see this very clear to this source of apportionment. And just some example, for example, on November 18, and from Taiwan Strait is 34%, from factory is 29%, and from Taichung power plant is 10%, and from the diesel truck is about 22%. So every day we do this. And this is some comparison between the model and also observation. And from Zhongmin station, this is the about 6 months simulation. And the dotted line here is observation. And also this bar, the stacked together is by my model. And also this green ones by CMAC model. You can see actually both models can do this simulation quite well. And also we can, PM2.5, we can partition into secondary pollutant, for example, sulfur aerosol. And sulfur aerosol, the observation also the red line here. And this yellow one is actually upwind, maybe from Taiwan Strait. But most sulfur aerosols come from power plant. For example, identify the top Taichung power plant is country most local source for this sulfur aerosol. But for nitrate aerosol, actually every time Taichung have a hazard days, actually it's nitrate that built up, for example, on November 4th. And we do this source apportionment in telling you this nitrate, most of them come from diesel trucks and some from power plants as well. So this for ammonia, we also do the source apportionment. For EC, organic carbon, we also do something similar, and also for the OC. So like this is like kind of my everyday life, try to improve this model. And we had do some like, we say the model evaluation and this observation for about 1 year. And this is the model by my model and also by famous Wolf-Schmidt model. You can see this map is quite similar, and this correlation coefficient is actually quite similar as well. And the standard error here. And we have summarized our just other software error, so not J also. Okay. This just summarize this correlation coefficient. For example, for CMAC, for this 1 year is 0.7 or model 0.76. Actually, that's similar. So we are quite confident with our modeling. Thank you very much.
Yeah, so thank you very much for your interesting presentation. So do you have any question?
Yes, please.
Okay.
Yes.
Yeah, so this is a quite an interesting talk to me because I know that there's a very good model to predict, which the scale is very small. So my question is that how about the resolution of the model? And also I know that in Taiwan, there's more interested in the long-run transport from China. So can you use your model to quantify or to determine the long-run transport versus local emission from China to Taiwan? This is also the most interesting topic that I'm following right now. Thank you.
Thank you. Yeah. Thank you, Professor Hu.
Yeah.
Yes. Yeah. Yeah. There's a huge debate about how much proportion from this overseas or from China. I would say it's not that much. Yeah, I would say about less than 30%. But sometimes because Taiwan is a very small island and we have a huge mountain. So if you use some model, for example, if you only use the result from high speed, I think they use the data from the NSAP model. American NSAP model is resolution about 20 kilometers. If you use the 20 kilometer resolution meteorological data, try to do the back trajectory, then you will find out most of your source is from China. But I just mentioned our model for the mesoscale meteorological model, we reduce to 1 kilometer resolution. So after using 1 kilometer resolution, you run the same model and the result completely different. So right now it's less than 30% or even 20%.
So that means you are more focused on the, I think it's Taichung, right? Taichung
yes,
is,
that's right.
Yeah, this area is a heavy industrial area. So
yes.
that's why maybe the contribution is not quite clear for this area also. But is it any kind of result from another side, for example, for the Taipei or maybe Kaohsiung?
Oh, okay.
Yeah.
Yeah, Taipei is much higher.
Yeah.
Taipei maybe more than 50, more than 50 from China or from, yeah. But
yeah.
Taichung is less than 30, Kaohsiung also less than 30. Yeah.
Yeah, thank you. This is also very interesting. And we are also would like to, maybe in the future, we can use your framework to develop one model for Vietnam, especially for the northern of Vietnam, where it is influenced by the emission from China every year, I think. Yeah.
Okay,
thank
yeah,
you.
be happy to. Thank you so much.
Yeah, so thank you very much for your presentation. So the other professor, do you have any question?
Yeah, no, yeah.
Okay, so now we have to move to another speaker. I would like to invite Dr. Nguyễn Lý Sĩ Phú from Vietnam National University, Ho Chi Minh City, University of Science, with the title of presentation, First Measurement of Atmospheric Particular Bound Mercury at a Super Megacity in the southern of Vietnam, Temporal Variation and its driving factors. So, Phú, please.
Okay, so everyone can hear me? Hello?
Okay.
Yeah, thank you. So, good afternoon, everyone. I'm Phú from Faculties of Environmental and Vietnam National University. So today, this is my pleasure to give a talk to everyone, and my title is First Measurements of Atmospheric Particulate Powder Mercury at a super mega city in the southern of Vietnam. And my focus is about the temporal variation and also the driving factor behind the variation of atmospheric mercury. And as Professor Hiên already give us some general information about the heavy metal in Ho Chi Minh City and also the effect of the particulates in Ho Chi Minh City. Therefore, I'm not focused on this part and just go through to introduce why mercury is important in the atmosphere and why I focus on atmospheric mercury. And here, this slide showing you the atmospheric mercury cycle. And as far as we know that mercury is the global toxic bioaccumulated pollutant. And for the cycling of mercury in the environment, atmosphere being the primary pathways of the global distribution. And in the atmosphere, we have three forms of mercury. We call gases elemental mercury, gases oxidized mercury, and particulate powder mercury. And we usually use the term ppm. And as we can see in the picture, for the particulate powder mercury, it can emit it directly from the anthropogenic emission, or maybe there are some secondary source related to the atmospheric processes. So that means the atmospheric mercury, particulate powder mercury, is important in the environment and also important in the atmospheric mercury cycling. Therefore, this study, we are focused on the particulate mercury. And next, I'm showing you the distribution of mercury emission worldwide. And as you can see on the left-hand side, there are several major sources of atmospheric mercury surrounding this area, and this is the East and Southeast Asia region. This has been regarded as the largest atmospheric mercury emission source worldwide. And also some of the observation studies recently show that the BPM concentration in urban side of Asia have a significant higher concentration as compared to another side in North America, Europe. And for the spatial distribution of the observation data, you can see that there are several observation data from China in here. However, for the Southeast Asia, particularly for Vietnam, there's no ppm studies has been conducted so far. Therefore, in this study, we aim to first investigate the characterization of the PM10 mass concentration and the particulate powder mercury ppm10 at the urban site in Ho Chi Minh City. And it should be noted that this is a super mega city in the Southeast Asia, with the population is more than 10 million. And we tend to make the comparisons to other studies worldwide. And finally, we studied the temporal variation, and especially to assess the driving factor behind the variation. So first of all, I show you this is the sampling site in Ho Chi Minh City. And our sampling site is located in the southern of Vietnam. And here, this is our site, the black star, and it's located in the urban side. And the site is in the University of Science, and we're sampling in the rooftop of the air monitoring station, as we saw in this figure. And we use the high volume sampler HV500 from Sibata, with the cut size is 10 micrometer. And we use the flow rate around 500 liters per minute, which can facilitate for 2 hours sampling. And that's why we can investigate not only the seasonal, but also the diurnal cycle of ppm and also PM10. And we sampling total around more than 200 samples, which is covering the dry and also wet season from 2018. And for the mass concentration of PM10, we use the microbalance to determine. And next, for the mercury analyzer. So after we collect the particulate, so we analyze ppm by using the direct thermal mercury analyzer, DMA, M3 solar system from NIC, Japan. And on of the QA/QC procedure is following the US EPA 7473. And in addition to atmospheric mercury, so meteorological data also collected from the nearby meteorological station. So here I'm showing you some of the results that we got. First of all, I make the comparison between our results to another study worldwide. And as we can see that the concentration of particulate mercury in Ho Chi Minh City is around 70, and which is comparable or just a little bit higher than another site in Taiwan, Korea, or United States. However, it's quite low if we compare with another site in China and even Nepal. However, if we consider the ratio between ppm and PM, this is the mercury, how much mercury contained in the particle. So the result from the Ho Chi Minh City is significantly higher than the site in Korea. And another site, we didn't get the information. And also there's a similar to what has been reported from site in China. And the reasons of the high mercury content may be because of the industrial activity or anthropogenic emission. And we also have some data from raw dust in Ho Chi Minh City. And the concentration we got is around 0.15, which means this is 10 times lower than the concentration that we got from the particulate mercury in the atmosphere. So it's also one of the indicators for the high enrichment of mercury in particulate matter in Ho Chi Minh City. And next, we take a look for the seasonal difference. So first, for the PM10, we can clearly see that the PM10 mass concentration in the dry season is significantly higher than the wet season. And for the continuous monitoring PM 2.5, we also can see that's the clear pattern, and this is the very consistency between these two data. So we can be confident about our data sets. And for the particulate mercury, so first for the particulate mercury with the units of picogram per cubic meter is also high in the dry season as compared to the wet season. However, it's interesting to see that in the dry season, the concentration, the mercury power to particle, the ratio is lower or just a half in the wet season. So in general, we have two conclusions why seeing this kind of pattern. First, the richer ppm10 in the dry season is maybe due to the higher PM10, while the higher mercury content we found in the wet season. And there are several factors can influence this, including the emission and meteorological factor, which is influence the scavenging or the gas particle partitioning. Therefore, we investigate first for the meteorological factor. We compare between the dry and the wet season. And as we can see on the graph, there's a quite similar in the temperature between the dry and the wet season, and also for relative humidity. However, we can see the significant difference in rainfall and also wind speed between the dry and the wet season. And there's relatively higher wind speed and significant higher rainfall in the wet season, which induce the scavenging or the dry deposition of PM and lead to the reduce of the ppm10 concentration. And next, we are investigate the correlation. This is one of the indicators for the mercury source. And we see that the ratio of ppm to PM is correlates significantly with the PM10. That means when PM10 increase, the mercury content in the particle also increase. And based on the literature review, so this similar indicates for the similar of anthropogenic emission source. That means the primary emission, or maybe due to the gas particle partitioning process, or the secondary one. And we also noted that the wet seasons have a better correlations than the dry season. It may be because of another factor or different in emission source. Therefore, we use the backward trajectories to determine the air mass transport pattern and the source origin of the ppm10 in Ho Chi Minh City. And as you can see in the left-hand side, there's quite a difference in the air mass transport pattern. In the west season, most of the air mass from the west and the southwest region. West in the dry seasons, there's the north and northeast wind dominate. And those kind of north and northeast wind may contribute to the transport of pollutant from China to Vietnam also. But we are not seeing this yet, so more data analysis need to be done to prove this assumption. And look at the local emission. So on the right-hand side, we have several industrial zones in Ho Chi Minh City and also the adjacent district. And from this map, you can see that for the west and southwest, also the north and northeast, there's a lot of industrial zone which can contribute to the elevated of atmospheric mercury at the sampling site. This is the yellow triangle here. So our study showed the significant difference in the ratio. This also indicates the difference in characteristic among the industrial zone in Ho Chi Minh City. And next, we are investigating the diurnal variation of the ppm and also PM. And for the right-hand side, we can clearly see that in both wet and dry season, there's a very clear band of the elevated of particulate matter, and it's located in around 6 a.m. to around 8 p.m. in the west season, and a little bit shift to 4 a.m. to around 6 p.m. in the dry season. However, if we look at the diurnal variation of the ppm, that's quite different, and especially there's no elevated of ppm during this time. It is around noon time and to this early of the afternoon. So this also possible for the contribution of the mercury gas particle partitioning, as we know that this is one of the major factors controlling the ppm in the atmosphere. Therefore, we also investigate the distribution, diurnal distribution of the temperature during the campaign. And we can see that for both wet and dry season, the temperature is rise up at around noon to the afternoon time, which is here. And with this kind of high temperature band, this can accelerate the mercury, oxidized mercury transformed to the gas phase. So that means this is lower ppm concentration at all. And in general, these patterns also indicate the process of gas particle partitioning of particulate powder mercury formation at the urban area in Ho Chi Minh City. So that means we illustrate for two mechanisms, primary emission and also secondary formation. So finally, I give some general conclusion. This is the first observation study of particulate powder mercury conducted in not only Vietnam, but also in Southeast Asia region. And although the concentration of mercury, particulate powder mercury in Ho Chi Minh cities are lower than in China, however, the ratios were found to be similar. It's suggesting the high enrichment of mercury in PM10 due to the anthropogenic mercury emission. And the ppm10 concentration in dry season is higher than in wet season. It's the major mechanism driving is the effect of wet and dry deposition. And the ratios reveal that the air mass from west and southwest region of the sampling site carry more mercury than the north and northeast region. And both primary and secondary source play a vital role in the variation of the ppm10 in Ho Chi Minh City. And that is all of my thought. Thank you for your attention.
So thank you very much for your presentation. So just 1 minute left. So do you have any question? I think just one question for Dr. Fu.
Yeah, it's very nice presentation. I'm curious why the mercury to PM ratio is similar to China. Have Vietnam do any control on this Hg or mercury or not? And why it's coming from the west? I just cannot understand. Yeah.
I think first question is any kind of application to control the mercury in Vietnam. I would say no, because actually until this time, the present time, we are not have any kind of like professional data for atmospheric mercury observation in Vietnam. Therefore, I think the government didn't have any kind of contract, any kind of active to reduce the mercury. And you said that the elevated of atmospheric mercury from the west side, right?
Yeah, that's right. It's higher than the east side.
Yeah, actually, it's from my presentation, I emphasize that the high concentration of particle also induce the high concentration of atmospheric mercury. However, it may be not only due to the local emission, but also due to some transport. And this is the further, we also work for this kind of topic to further investigate where it's come from, maybe from China, or maybe it's just because of the local emission. But different wind patterns can bring different pollution to our sampling site.
Thank you.
Yeah.
I know in Taiwan, they try to control mercury from power plants. They use like a lower content of mercury coal. Yeah, when they buy the coal. So I'm wondering, have you doing something similar or not? Yeah.
I think not, because the treatment of the coal in Taiwan, I think it is the water to truth, and it's like the coal benefit. But in Vietnam, I didn't hear any kind of information like this before. And also, we are not have a very good emission inventory for mercury in Vietnam nowadays. Yeah.
Thank you.
Yeah, thanks.
So thank you very much for your interesting presentation. So I would like to close the first session. Again, thank you very much for all professor in the session 1. And now maybe we will have the 5 minutes break and we will start to the session 2. So thank you very much.
Thank you very much.
Yes.
Không có rồi. Nó phải nói rồi. Đây là nó đang có. Chưa ai nói. Giờ thì mở rồi.
Could you maybe make sure? I want to make sure you can hear me on your side. No problem, right?
Yeah.
Okay.
Okay. So now we are going to start our second section, and in this section we have 4 presenters. Okay, and please, because we have to control our time. All right. So the first speaker is from Vietnam, and I think it should be she or he. It's Dr. Latu Tam, and he will present the first one. So let's welcome Dr. Latu Tam.
Yeah, thank you, Professor Chairman. Okay, this one. So, good afternoon, everybody. My name is Thanh. Today, I would like to talk about the synthesis of lactobacillus, zeolite, and US absorbent for removal heavy metal and radioactive metal ion from water. So, this is content of my talk: introduction, material and methods, and result, and finally conclusion. First of all, zeolite are the microporous aluminum silicate material. It commonly used for absorbent and catalyst. This is the structure of the zeolite. The center, the silicon or aluminum connect to 4 oxygen atoms to make the tetrahedron, and CBO connect together to form the framework structure. So depend on ratio silicon and aluminum ratio. We have many kind of zeolite, and zeolite we can use for many industrial applications. Now we have 2 kind of zeolite. First one, natural zeolite. This occurs in the rock and contains the other material and low purity. But natural zeolite very cheap. Opposite natural zeolite, we have synthesis zeolite. The structure very uniform and high purity and stability. So, but the cost higher than natural zeolite. So the characteristic of zeolite, we because in structure of zeolite is material is very suitable in high temperature or in alkaline medium. So the set in the structure depend on the bond size of zeolite. So the shape can selectivity for the separation of the molecules. And in zeolite contain flexible ion that it can exchange with the other anion. So we can use for the water treatment to remove the heavy metal. And the other one we can use because in zeolite structure we have high specific areas, so we can use zeolite for absorption. Yeah. Here I would like to show you some application of zeolite. So first of all, we can use zeolite for the catalyst to do the cracking reaction in the oils, petroleum industries, and we can use zeolite to add in detergent to remove calcium and magnesium ion to make the to remove calcium ion and magnesium ion. And the other one, we can use zeolite to make the membrane to separate the gas mixture. This is a bit the same professor who is Sing Chen present before. So in our group, we already published 2 papers. We use zeolite to make the membrane to separation the mixture of CO2 and CH4 recently. So now we developed the zeolite to remove heavy cation, heavy metal, and radioactive ion. So in this research, we synthesize zeolite, LTL, and MOR, an application to remove the heavy metal in aqueous solution. So we control the ratio of silicon and aluminum to make the 2 zeolites with the ball size here. The next one, I would like to show you the method to synthesize zeolite. The first one, we synthesize zeolite LTL. First of all, we mix potassium hydroxide in the dilution water, and then we add in aluminum hydroxide to and stay around 500 rpm for 1 hour to make the uniform solution potassium aluminase. And then we add in silicon solution Ludoc AS40 to make the white gel, and then we transfer white gel into the vessel, and we do the hydrothermal reaction at 170 degrees C for 3 days. After that, we filter the zeolite and work with the dilution water and dry, and then we obtain zeolite L. Similar to synthesize zeolite L, we synthesize zeolite MOR with the same one, but we control the temperature, reaction temperature, and ratio silicon and aluminase to obtain modernized zeolite. After we successful to synthesize zeolite LTL and modernized, we test the characteristic of the zeolite by using the same HRD and EDS spectrum. Then we do the reaction to removal anion, heavy cation, and radioactive cation in aqueous solution by using batch reaction. So in this procedure, we use 0.1 gram zeolite, and we add into 100 milliliters aqueous solution containing single ion, for example, cadmium, copper, cesium, lead, strontium, and zinc. And we carry out the optimal condition by using the contact time and initial concentration and for two zeolite, LTL and modernite. And we use frame AAS and ICBMA to monitoring the ion in the solution after, before treatment and after treatment. So this is the result. So in this picture, you can see this is the structure of this is the image of LTA zeolite, which is structure, and we use this is the spectrum which we compare to the LTL zeolite with the zeolite we LTL we synthesize. You can see almost the same, the main peak, and also modernized zeolite also almost the same. So we conclude that we successful to synthesize zeolite LTL and modernize. So this is the result of the effect of contact time on the absorption capacity. In this figure, you can see the absorption time to obtain equilibrium state for the almost heavy cation ion obtain around 10 minutes. Obtain about 10 minutes. And the effect of contact time absorption capacity for the strong tea around 40 minutes. Yeah, lower than around 40 minutes. Or this is the effect contact time on absorption capacity for zeolite modernized. Here you can see absorption process for lead and cesium ion occur partly and partly than door of metal ion, the other metal ion. And these figures give you the information of the initial concentration metal ion on the absorption capacity. So in this case, you can see the cesium and lead ion which have higher than concentration higher than the other ion. So in these figures give you the initial concentration of metal ion absorption capacity on the modernized zeolite. So the optimum condition for lead around 170 milligram per gram zeolite, and cesium 238 milligram per gram material. So we carry out the reaction modeling to investigate the kinetic of reaction. So in this research, we do two models. The first pseudo first order model and pseudo second order model for both material. You can see the result R square in for the LTL zeolite and modernized zeolite. with the second order model, the best fit for the two material. And we investigate the absorption modeling for Langmuir and Faudis isotherm model. From the result, you can see the R square for Langmuir model higher than Faudis model. So we conclude that the absorption model perfect for this experiment, Langmuir model. So in conclusion, in this experiment, we successful to synthesize LTL zeolite and modernized zeolite, and we apply to remove heavy metal and radical active metal ion with high efficiency. For example, the result gives you zeolite LTL modernized have high absorption capacity with the capacity 279 milligram per gram, emeraldite 288 milligram per gram, and for less iron, LTL 141 milligram per gram, and emeraldite 170 milligram per gram. The experimental data fit Langmuir isotherm and pseudo second order kinetic model, and monolayer chemical absorption process in this experiment. Well, thank you for your attention.
Okay, thank you very much. Very interesting. But because we are behind the schedule, so only one question, please. Any question? Please.
Professor Tan, thank you for your nice presentation. And your research work is very interesting. You prepared the LTL and the MOR zeolite for mental absorption. My question is, after absorption, how to regenerate the zeolite? Thank you.
Thank you very much for your interesting question. So in zeolite, so we try to reuse zeolite by using the sodium chloride with high concentration to exchange the cation captured in zeolite, but we cannot remove because when zeolite absorb the heavy metal in the structure, so it's very hard to remove the heavy ion in zeolite structure. So after we do experiment, we can keep the zeolite containing heavy metal, and we dump and we store, so we cannot reuse the material.
Okay, thank you.
Okay.
Maybe you can use as the catalyst for other permanent degradation. Thank you.
Yeah, thank you.
Okay, because we have behind the schedule, so if you want to have time for discussion, you can shorten your presentation time. Now, let's welcome the second speaker, Professor Chen. Please.
Hello, everyone. Good to have you in this webinar. I am Jiaying Chen, and today I'm going to introduce So my major research interest is applications and implications of emergent materials, and including 3 parts. First is development of environmental sensing system. And second is investigative fate, transport, and environmental photochemistry of emergent material. And third part is the catalytic degradation and stability of organic pollutants. So in today's webinar, I will majorly focus on the first part to develop an environmental sensing system in aquatic system, and a little bit about the second part. So for the first part, for the environmental sensing system, our research goal is to build to electrochemically determine emergent contaminant in aquatic system. And we intended to use a sustainable approach to fabricate the electron for the detection. So why we need to detect the emergent contaminant, including antibiotics in the environment? This figure shows a worldwide increasing antibiotics. And you can see that with this increasing usage, it has been reported that a significant amount of the consumed antibiotics, either for human or for veterinary, it won't be completely metabolized. So the residual antibiotics will be discharged into the environment in the wastewater treatment plant, the effluent, or in the effluent of the hospital, or from the agricultural runoff, or in the livestock farm. So you might wondering then, what will this residual antibiotics do? So they will cause a proliferation of the resistant strain of bacteria or a growth inhibitory of the green algae. And for our human, we may add as a passive consumer, and these discharging drugs may disturb our enzyme system or cause allergy reaction or alternate our intestinal microflora. So for the drugs imported in Taiwan, you can see on the left, the antibiotics are of the greatest amount. And among the antibiotics, the penicillin and sulfonamide are the top 2 imported in Taiwan. So the sulfonamide is one of the most widely used antibiotics from 1940. And sulfamethoxazole is a representative sulfonamide. And this sulfamethoxazole, we call it SMZ. This SMZ has been widely detected in surface water, either in US or in Europe, especially in Germany. You can see a very high concentration in Germany, and also in China. So because the SMZ has been frequently detected in all kinds of water bodies, including you just see in river water, and also in the effluent from the wastewater treatment plant in groundwater. So making a real time, and you just see they have the negative effect either for human or for wildlife, for bacteria. So making real time and in situ detection of them is highly desired. So in this study, which is the SMD as our target compound to detect. So traditionally, a lot of analytical, either the chromatography or spectroscopy techniques can use to detect the SMD. However, they usually required high maintenance or operation fee and tedious sample pretreatment. So on the other hand, we propose to use the electrochemical approach to detect because they have several advantages, including fast response and simple operation. And most important, they are promising for real-time detection. So in our study, we're using 4 different carbonaceous material. And you can see the third one is a graphene oxide reduced by a commonly used reductant, hydrazine. And hydrazine is a commonly known hazardous toxic chemicals, either for human or for the environment. So we propose to use a green reductant, ascorbic acid, to reduce the GO and to compare the performance to the one reduced by hydrazine. So in the result, you can see that on the third row, the third column, you can see that the one reduced by the hydrazine, they actually have the different on the graphene surface. And this may contributing to its less electrical performance. So as we probe by the CV curve, you can see our RGO reduced by the ascorbic acid has the highest electrical chemical performance compared to the other sample. So it shows that either by this mild and green and environmental friendly reduction in ascorbic acid, it can still reach a high performance of the to reduce the GO as a good candidate for the electron. So in the chemical composition, you can see that on the last row, the one reduced by the ascorbic acid, it has it can remove the surface functional group better than the others, and this will contributing to a higher affinity to our target compound. Because the SMZ at neutral pH, it will tend to form a planar-like conformation. So with our RGO has fewer functional group on the surface, they have a higher pi-pi interaction, so increasing the selectivity and sensitivity. And high stability and good recovery from real water sample has been found for our developed electron. So in this part, you can see that we're using a green reductant ascorbic acid to reduce the GO as the ARGO, and it shows a promising feature to detect the SMZ in real water sample. And next, the bisphenol A, which is so-called the BPA, is a widely used industrial chemicals of raw material to make the plastic or epoxy resin. And it has been found in water and food samples. Because the BPA is a reported endocrine disruptor, so to detect the BPA leaches into food or water samples is very important. So in our work, we propose to use the terracinase to modify a carbonaceous material. Terracinase is an oxidase, and it can catalyze, you can see the figure below, you can see that it can catalyze diphenol into catalyze the monophenol into diphenol and further into quinol products. So this catalytic transformation can facilitate its detection efficiency of phenolic or aromatic compound, including our BPA. So, but the question is the terracinase with the isoelectric point at around 5. So it's negative charge at neutral pH, which may curb its forming a stable assembly with our RGO, which is also a negative charge. So then we use the chitosan as a bridging linkage. Then we are wondering, what is the functionality of the RGO while affecting the construction of this composite, and further to affect the detection efficiency to the BPA. So then we use carbonaceous material with different functionality. And on the on the right-hand side, you can see that with the reach of carboxylic group, it has it can promote the amine linkage with the chitosan. And with that, to facilitate its formation a stable assembly with the terracinase, and to reach a sensitive and selective detection of the BPA. So this is the second part for detection of the BPA. So then for the second part is the fate, transport and environmental photochemistry of engineered material. So we are wondering what's going to happen when all those emergent engineered material, when they enter into the environment, what's going to happen? So in this part, our research target is the molybdenum disulfide. It's one of the TMDC material. So we are curious about what's going to happen when they enter the natural environment. And we found that you can see the picture below on the very left side. You can see that after around like 3 months, it underwent progressive deterioration in water system. However, in the presence of natural organic matter, it can retard, it can slow down this oxidative degradation. Then, so this is under dark environment, and this is its chemical phase transition. And interestingly, you can see that you can see that under sunlight irradiation, the humic acid will actually accelerate the aging of the molybdenum disulfide. So overall, you can see that the transformation of molybdenum disulfide, it's environmental factors dependent, either the exposure condition, like whether you have the sunlight or not, and also what is the environmental macromolecular, like what is the natural organic matter present, will all affecting its environmental behavior. So okay, so with that, it's a very brief introduction of my research interest of this the first 2 parts. So thanks for your attention.
Very nice presentation. You control the time very well. So, anyone has a question? Hello. Hello. Can you hear me? Hello, can you hear me? Is anyone has question? 断线了。啊？ So, because if we cannot connect with the other side, we have to talk by ourselves. Hello.
Hello.
So did you miss the presentation or not?
No, we still following the presentation.
Okay, so do you have any question?
I think it's fine. I don't have any question now.
Actually, we cannot hear you very clear. Okay, because we have time limits, so maybe we have to go to the second speaker, right? Because we spend a lot of time on the internet connection. 好，那我们就第3个 ，OK, okay. Because now we are going to the third speaker. The third speaker is from Dr. Hu. So he will present
she will present her topic. So it's now okay? You ready?
Yeah, I'm ready.
Already? Okay, please.
Dr. Hugh?
Hi, I'm here.
Yeah, would you please turn the volume up a little bit?
Good afternoon, everyone. I'm sorry a little bit.
Oh, now it's good. Now it's good. It's good.
Oh, yeah,
Yes.
before my presentation, I just want to let you know that I'm sorry, my throat is not in a good condition so far, so I can't speak loudly and my voice a little bit not clear for you to listen, but I will try my best to speak slowly and pick up every
Okay.
single.
Okay. Thank you.
Good afternoon, everyone. Thank you very much for your attending to this conference and give me opportunities to present my research topic. Today, I'm going to present a research topic about assessment of drugs and personal care products, biomarkers in the influence and effluence of two wastewater treatment plants in Ho Chi Minh City, Vietnam. So this is one of the work of my PhD thesis when I did my PhD in the University of Queensland, Australia. So yeah, in recent years, there are growing concerns about the emerging contaminants. There are a lot of different chemicals categorized like emerging contaminants, and where are they? Where are they from? Yeah, there can be from drugs. It can be like illicit drugs, or they can be from the personal care product that we use in daily life, or these chemicals can be also from like some drug and some products, consumer products like clothes or cooking, non-stop cooking. So all the chemical after human use, they go to the environment through this pathway from the industry, from hospital, household, and from agricultural activities. All the chemicals at the end they release and enter the wastewater treatment plant. And after the wastewater treatment process, some of these chemicals are discharged to the environment, to soil, to water, and at the end they reach to human and cause some health effect. So how about how these chemicals stay in the wastewater treatment plant? And we know like why we call these emerging contaminants, because the chemicals, they are persistent, they are bioaccumulative and have some potential toxicity. So because they are due to their persistence, so some of chemical after the wastewater treatment process, they are still remain in the wastewater, and then at the end they released into the environment. So that's the reason why some of PPCP recently have been detected at the concentrations from 10 nanogram per liter until hundreds of microgram per liter. And after wastewater treatment process, these chemicals also found at the concentration from LOT to tens of nanogram per liter. And some of hydrophobic chemical can be found in the biosolid. So that's the reason why I come up with this topic for my PhD project. And this is the aim of my PhD, a chapter of my PhD project. Now I investigated the concentrations of some emerging contaminant. In this topic, I call it like drugs, personal care products, biomarkers. In the influence, we try to understand the occurrence and the consumptions of these chemicals in the population in Ho Chi Minh City, Vietnam. And at the same time, I also investigated the concentrations of the chemical to understand how much they were released into the environment in Ho Chi Minh City, so that we can understand the environmental distribution, environmental burdens, and potential risk. And at the same time, we use the result from influent and effluent to understand how this chemical can be removed from the wastewater treatment plant in Ho Chi Minh City in Vietnam. So to do this, I approached these methods. I collected wastewater samples into wastewater treatment plant in Ho Chi Minh City in 7 days in a row. And in each day, I collected grab sample in 4 interval times every 6 hours. So after sample collected, I freezed and then transported all of them to Australia and preserve them until in frozen until analysis. Yeah, before analysis, I put all sample like 4 grab sample in 1 day become 1 day sample, and then I filled 1 ml of each sample using RC45 micrometer filter before I spike internal standard. So then I analyzed with LCM SMS triple quantity 500. The methods, the analyzed methods was developed by Queensland Health Forensics Scientific Service. So this is the results of my study. Actually, I analyzed more than 100 of compound in the group of PPCPs and nicotine and personal care product biomarkers, and this we found the all chemical that we detected. The first one is methamphetamine. The second one is morphine, codeine, cotinine, hydroscotinine, nicotine, carbamazepine, gabapentin, ibuprofen, iopramide, naproxen, paracetamol, salicylic, diazepam, DIT, Deodorant, acesulfam, caffeine, prazosin, and ethyl sulfate. This is metabolized of alcohol. So we find, in general, we found like the concentrations of the chemicals is higher in wastewater treatment plant B than wastewater treatment plant A. And among these chemicals we detected, we found like caffeine and paracetamol have greatest concentrations. You can see it in the figure. And we compared this result to the other studies around the world, and we found like this level is quite similar to the level that's found in Asian countries. And at the same time, we also try to understand how this vary between days, the daily variation of these chemicals. And we only saw like nicotine and ethyl sulfate is increased at weekend. You can see it's like the green light and the pink light. In opposite, we found iopramide decrease at weekend compared to the weekdays. So that's we explain. The reason is maybe at weekend people like tend to use more nicotine and ethyl sulfate. They drink more alcohol. They go to bar and they have like more parties. So that's why they release more ethyl sulfate. We release more into the wastewater. With iopramide, this is a chemical that's used in the X-ray scan in the hospital. So usually at daytime, the weekdays in the hospital, they use this one more to take the X-rays for patients. So that's why you can see it's like the higher concentration is weekdays compared to weekend. So then after that, I use the concentration and I brought the methods we call epidemiology wastewater analysis. So try to measure how much these chemicals consumed by the population in Ho Chi Minh City. In the catchment, release the wastewater to these 2 wastewater treatment plants. So you can see on the slide is the formula where I used to calculate the consumption with the gram per day per 1,000 people. So C, which means the concentrations of the chemical, F, the flow data of the wastewater treatment plant, P is the population data, is excrete rate, and MPAR, which means the molecular mass of the parent compound, and MNET is molecules of metabolites. And when we calculate and we found, with high concentration, caffeine and paracetamol show very high consumption in this city. And besides that, temazepine and salicylate also quite high, ibuprofen and nicotine. And we compare this result with the results measured in Australia and in China. And very interesting, we found the level in Vietnam and in Australia, like acesulfam, iopramide, is quite comparable to, and between 3 countries. But to the other compounds, you can see in Australia is higher, and some of them quite comparable to Vietnam, but in China is much lower than in Vietnam and in Australia. So next, after that, I also try to calculate the remove for efficiencies of this compound into the wastewater treatment plant. So in general, I found the wastewater treatment plant A shows lower remove efficiency than wastewater treatment plant B. The A is in green color and the B is in blue color, you can see here. And some of them, we even observed the negative removal like gabapentin, iopramide, and diurins in wastewater treatment plant A. And as you know, the reason why, the next figure I showed the total discharge, the reason why I tried. In Ho Chi Minh City, we have like more than 10 million population, but so far we have 2 or 3 wastewater treatment plants. And of course, this wastewater treatment plant can't serve all the wastewater released by the whole populations in Ho Chi Minh City. So that's why I, based on the mass of this compound released into the wastewater, to estimate the mass of this compound are released without like treated and untreated of this compound in Ho Chi Minh City. So I found that total around more than 200 kilograms of this chemical were released into the environment or water environment in Ho Chi Minh City per day. And among these chemicals, acesulfam, caffeine, paracetamol, and salicylic acid were released more than 10 kilograms per day to the environment. And carbamazepine, codeine, and morphine shows lowest level. And if you want to have more information about this, you can find more detail in this paper published in Stoughton. And at the end, I would like to acknowledge my supervisor and my team in Australia and the scholarship. And thank you very much for your listening.
Thank you so much. Very interesting. So now it's time for asking a question. So any question here?
I will ask one question, Dr. Hugh.
Yep.
I'm just really curious about all the analysis. So where did you perform your chemical analysis? Because I think your PhD is done in University of Queensland, but the samples are from Ho Chi Minh City. Is that right?
Yes.
So you perform your analysis in Ho Chi Minh City or in Queensland?
Yes, I did analysis all my samples in Australia, in my lab in Australia. I collected my sample in Ho Chi Minh City and then freeze all of them and then transport it to Australia for analyzing. So yeah, all analytics were performed in Australia.
Wow. Okay, I see.
Okay, that's I would spend a lot of money for transportation. Please.
Thank you so much for your presentation. Because you say you transport the sample from Vietnam to Australia, so I want to ask you about where are you the wastewater treatment plant in Vietnam? You take the sample where?
Where?
Yes, because you say through Vietnamese wastewater treatment plants.
So I collected the sample in the wastewater treatment plant in Vietnam, in Ho Chi Minh City. Yes. Yeah. So then I freeze off them. So then I brought them together with me on the flight.
Which district?
In Ho Chi Minh. Yeah, we have only 2 wastewater treatment plants.
Okay. Thank you so much.
Yeah.
Okay, so thank you so much, because we are behind the schedule for 25 minutes. so please, thank you so much. If you have any question, you can contact privately. Okay, next speaker is Professor Vin Jun. That's me. Okay, and I will present my topic shorter, and I hope we have time for discussion. Okay, and my topic is application of Okay, so this is my topic. So for saving time, I don't want to read it again. Okay, such as apply food isolation process for the industrial wastewater treatment. Okay, this is my outline. So I want to introduce what is advanced oxidation process. Okay. And the second is what are Fenton process and its limitation, and I will show you what the advantage and how to scale up an application. Okay, so we have two measure because our background is very different. So I want to know and let you know why we have to use apply the advanced oxidation process. Next, please. It works. Okay, because in general we always use a biological process to treat the wastewater, but sometimes the water contains some toxic chemicals, so you cannot use a biological process. So no choice. We have to apply advanced process. Okay, and among of this process, I focus on the Fenton process. Actually, in the beginning, why I focus on Fenton process? Because it's cheap. Because I don't have to buy a lot of instrument. Reactor is very easy to mix ferrous ions and hydrogen peroxide together, and I can correct data. That's my motive for doing this kind of research. However, okay, I will introduce what's the Fenton process, because the process is because ferrous ion react with the hydrogen peroxide, produce hydroxyl radical. Then this is the product. So the hydroxyl radical will oxidize organic pollutants. And okay, and ferric, the product ferric will react with hydrogen peroxide. Then we got a ferrous ion again. That's so iron is the catalyst. But when we apply Fenton process, then because we use hydrogen peroxide, and hydrogen peroxide will react with the reductant in wastewater. So sometimes you mix ferrous ions and hydrogen peroxide in the wastewater, then just produce oxygen only. no hydroxyl radical. That it is at this kind of condition, no oxidation reaction. And another problem is because we add too much hydrogen peroxide, we react with hydroxyl radical, and it just waste our radical and waste our oxidant. And the last one is hydrogen peroxide is not very stable. So sometimes you on site, you will find a lot of oxygen produced. And okay, another problem is if we apply fermentation process and we have to remove iron species by increasing the pH. And this is the iron sludge. And the iron sludge will float on the surface. So it's impossible to remove. The efficiency is very bad. So this is the problem, another problem. Okay. And another, when we fermentation process, the agent also include ferrous ions. And the ferrous ion, because of the pH, the problem, because pH. So this kind of process, we have to operate at around pH 3. So that means if the wastewater pH is higher than 7, or you have to decrease the pH. So we add a lot of acid. And this is a kind of a problem because we use ferrous ions, right? And this kind of ferrous ion or ferric will complex with some ions, especially if the wastewater contains chelating agents. Almost quench the reaction, almost stop. See, that this is for phosphate. If the water contains phosphate, the phosphate will complex with ferrous or ferric. Then you got this kind of new complexation agent. Then almost a reaction. So this is the problem. Okay, and okay, it's the same. Sorry. Okay, and as I mentioned earlier, we have to increase the pH, and then the pH, the iron will be iron hydroxide will be generated. Then got a lot of sludge. But even we are after the watering, they still have a lot. The sludge still contains 70% of water. If we have to treat the sludge, you can imagine we spend 70% of money for water only. So just if we treat the sludge like this way, we just waste our money. Well, okay, that's the problem. We want to apply fermentation process. Okay, see, this is the sludge from the fermentation process. Even after the water, you can see it's like a solid, right? Very dry, but after analysis, you can find the moisture is always higher than 70%. So that's the problem, because we want to apply the process. We have to spend a lot of money for the sludge disposal. So, okay, this is the case. See, the first time, this is the first case. We apply some fermentation process. You can see in the reactor, a lot of iron sludge is produced. And but the treatment efficiency is very high. So you can see the carbon removal almost completely. But after the watering, this kind of a sludge, a lot of sludge, the water moisture is around 70%. So what's the solution? So this is the solution for a fermentation process. Okay, and traditionally, as I mentioned earlier, the sludge contains a lot of sludge, right? But we apply crystallization method. Crystallization method is, the mechanism is, we put a carrier inside. And see, this is the fermentation process. Ferrous ions react with hydrogen peroxide. And then we produce hydroxyl radical and react with organic pollutants. By this way, we can oxidize organic pollutants. And when this ferrous react with the hydrogen peroxide, we produce ferric, and the ferric will react with hydrogen peroxide and go back reduced to failures. Okay, this is the traditional process, traditional fermenting process. But we put the carrier inside, and the iron will crystallize on the surface of carrier. Okay, then the carrier has the ability to catalyze hydrogen peroxide to produce hydroxyl radical. Then compared with the traditional one, then this kind of process will produce much more hydroxyl radical. And another important factor is, since this is a kind of iron oxide in the reactor, it also has the absorption ability. So in this reactor, you can find oxidation and the absorption reaction happens together. Just why this process has higher efficiency than the traditional one. This is some data we compare traditional fermentation process. The traditional fermentation process means I mentioned again ferrous ions and hydrogen peroxide. Then fluidized bed is we build up a fluidized reactor, and then we put the carriers inside. So the fluidized bed always have higher efficiency than the traditional fermentation process. Okay, this one also show a fluidized bed has higher efficiency than the traditional one. Okay, so also show the data also show the fluidized bed also is better than traditional one. Okay, this is another case. We treat textile wastewater, and you can see from in the beginning is the color, and after 100 minutes it's almost clear. So this kind of process can remove the water very well. Okay, see, this is the fluidized bed. Okay, and we have wastewater inside, reactor inside, and we have a crystal sheet inside and the crystallization on the surface. So we got a iron oxide crystal. Okay, this is a real crystal from the real wastewater treatment plant. So you can see the data. See, the data we calculate. So we can save for this kind of plant, we can save us $300 per day, but today, right? But the plant will be operated for whole year. So the whole year will save a lot of money. So because why I put the process here, because as I mentioned earlier, bioprocess is always cheap, but AOP, especially you have to pay I have to pay the cost for the oxygen. So always connect with traditional process. Especially now we apply the process after biological treatment. Okay, this is the scale up. In the beginning, it's lab scale, big one, still in the lab. But this is the pilot scale on site. Okay, and here you can see some real case. You can see the COD hydrogen peroxide COD removal, and this COD removal efficiency. Because now even we apply a biological process, even cannot meet the discharge standard because the COD always around 100. Because actually after biological process, sometimes it still cannot meet the standard. So we have to apply the fermentation process, and this fluidized bed fermentation process is good. So because this is our conference between Taiwan and Vietnam, so I show you some real case in Vietnam. This 5 standard polytechs in Vietnam, Prime Asia, and Chen Nong. We build up some real plan in Vietnam. how big the reactor? So big, right? Actually, this is the Vietnamese. He ever studied in Taiwan for 2 years in PhD, but for earning money, he want to go back to build up the real plan. So academic studies not very important for him. Okay, so finally, I would like to mention about the advantage because high flexibility because it's not you can increase the chemical dosage or reduce depending on the water quality and easy to operate. Just add chemical on because efficiency is very high, so it's shown oxidation and economic because it's cheap actually compared with RO activity absorption process or other process. Okay, this is another case in Vietnam. Okay, conclusion is FER. I mean, it's a kind of a technology as a polish unit, and before you want to reuse the wastewater, it's kind of can treat the water for reuse. And additional benefit is recover material with high purity from the wastewater, and also some managing new material, for example, like the seed. Okay, and we also can apply the wastewater treatment contain genetic agent in future. We still do the research because we want to apply this kind of process and or technology for more wastewater. Thank you. That's all my presentation. Okay, only one question because I talk too much.
So I have a question.
Please.
It's very interesting topic. So I would like to know because in the FBF technology we have to use the carrier. So what kind of carrier is as the most commonly used in the technique? And the second question is you said that you have applied some treatment in Bình Dương, Đồng Nai in Vietnam. So what is the cost for treating 1 cubic meter of wastewater? I mean the price for treatment. Yeah.
Okay, I know almost everyone very concerned the cost, right? Actually, yeah. the cost, if you mention about the cost, is it depend on the cost, hydrogen peroxide cost in your country. So the cost in different countries are very different. But I think it should be cost effective. Otherwise, impossible. We build up so many real full-scale plant in many countries. Actually, now in the world, I think over 50 food aspect fermenting process in the world. Yeah. So it's depend on the price. I mean, depend on the price. Actually, I have no idea about the price hydrogen peroxide in Vietnam, but I think it can be accepted. Otherwise, it's impossible. We have so many plants in your countries.
So how about the carrier of the system?
Oh, okay. Carrier actually is very cheap. Carrier we can use acetic oxide or some carrier because it's acetic oxide is the most common. It's the most common. Yeah, and as you know, acetic oxide is very cheap. Very cheap. It's no problem. But in the beginning, you have to use acetic oxide. But after that, you don't have to use it because you can get the granules in the reactor continuously. So actually, acetic oxide is for start the reaction. But after that, you don't have to add. Just get the new granule out. That's all. Keep the bed high.
Okay.
That's a constant. That's all.
So may we visit the treatment plant in Bình Dương or Đồng Nai?
Pardon, I cannot understand
so
what you...
I hear that you have some application in Vietnam.
Yes.
So may we go there to visit the treatment plant?
Oh, yeah. I did not visit the plant, but I hope I have the opportunity.
Oh, okay.
Okay, because yeah, that's about that's all Taiwanese company. So I hope Vietnamese company also can use this kind of technology.
Okay, yeah.
Okay, because time is very limited. Oh, thank you so much.
Yeah, thank you.
So we have 5 minutes for break. Okay, we have 5 minutes for break. Okay, thank you. See you later.
是那个 Hugh Trump Hugh Tran Van.
Yes, I'm here.
Professor Hugh Tran Van.
Yes,
Okay. Okay, everyone here. Now we'll start the very last session. Okay, it's remediation and biotechnology. Okay, so we will first introduce the first presenter from Vietnam. It's Professor Hugh Tran Van, and his topic is designed dual-headed proteins for biosensor development. Okay, we'll give it time to Professor Hugh Tran Van. Okay, so your presentation, please start.
Yes, thank you, Professor Suchi Chang. Everybody can hear me loud and clear?
Yes.
Okay, so good afternoon, virtual audience. So first of all, I would like to thank Professor Suchi Chang and Professor Toti Hing for inviting me to this cross-border webinar. So the topic of my talk today is design dual-headed protein for biosensor development. So next, I would briefly introduce about the lateral flow test. So I think most of you will know about this application. So do you know about the pregnancy test? I assume all of you know about this one. And it's a kind of lateral flow test. And later on, it can apply to detect different kind of disease like SIV, SPV, SPV, or even in food safety. And the market for this flow test is steadily growing, and approximately about 8.3 billion in 2023 in Asia Pacific region alone. And so what is the pros and cons of lateral flow test? The pros is simple and low price from manufacturing, and the response time is quite quick, about less than 20 minutes. And it's easily used by a non-skilled user. Even the kid can use it. And most of all, this can be used to diagnose at the place. I mean, it's easy to diagnose, but of course, it will come with a con. So this is the lateral flow test is non-quantitative, and it's quite low sensitivity. So you need a really high sensitivity antibodies. And for that, to improve the performance of lateral flow test, you need to improve the sensitivity of the test. So for those not really familiar with this test, I will briefly introduce about this test. The test is just a membrane, a different kind of membrane stuck on each other. So you have the sample part where you put the sample or analyze on this, and through the lateral flow, it goes to the other end. So one is past the conjugate part, there's gold antibody conjugate to the analyze, and it will capture, and it goes to either the test zone or the control zone. The test zone will let you know whether you get the positive or negative result, and the control zone to indicate whether this test works properly or not. So for the sensitivities of the test, you either increase antibody sensitivity or antibody immobilization. So what do I mean by antibody immobilization? Which means that if you can nicely immobilize the antibody, it can prevent protein slumping, and it can stereochemically immobilize antibody. So most of the membrane used in this test is nitrocellulose membrane. It's widely used in different kind of applications like Western, Southern, Northern, and this negatively charged as the neutral pH. and the protein absorbed onto this membrane via hydrophobic and electrostatic interaction. So there are a different way to immobilize protein onto the nitrocellular membrane, either by direct absorption via electrostatic interaction or covalent links by chemical methods. And the most well-known is using tetravidin-biotin interaction. But recently, there's a way to immobilize protein onto the nitrocellular membrane by using nitrocellular binding anchor protein. So what is it? This nitrocellular binding anchor protein is just a man-made stable structure. It mostly comprises of alpha helix, and the PI and the TM make it really suitable for different kinds of applications. And the most important thing that it's comprised about 25% of lysine, so it gives a better interaction with nitrocellular because it gives the protein positively charged, and it will interact with the negatively charged of the nitrocellular membrane. So we think that we can exploit the protein 3 helix to improve protein immobilization onto the membrane. But you know that the antibodies here, it have a toolbox, the FAB part, which will bind to the analyte, and the FC part will just make the structure stable. So if you randomly put the protein on the antibody onto the membrane, you will see they have a different kind of configuration. For example, the FAB can down or up or line on the surface. But the most wanted configuration is the FAB face upward, which means that the FC have to stand inward. So if we have a kind of protein, can I at least do that? Yes. So there's a native protein called protein A. It's a surface protein from Staphylococcus aureus. It has 4 FC binding domains. So which means that if we have the protein A, it binds to the FC, it will make the antibody stand out, and you make really nice chip. So we think that we can exploit the protein A to make the antibody stand out. So with this in mind, so we make a kind of fusion protein. So we will fuse the protein A either in 1 domain or 4 domains repeatedly with the 3 helix protein. And we hope that protein A will bind to the FC of an antibody, and the 3 helix will selectively bind to the nitrocellular membrane. So with that, it will have the antibody immobilization and prevent protein slumping. And with that, we can nicely get the nice antibody standing onto the membrane rather than the random distribution. So with that, we just want to fuse the protein A with the protein 3 helix, either with 1 domain or 4 domain of protein A. So with this approach, we do really simple approach using DNA techniques. So we do DNA cloning and recombinant expression to fill between the protein A, either 1 copy or 4 copies with the protein 3 helix. And then we evaluate the antibody immobilization and antibody capture. For the cloning strategy, I just simply fuse the gene of protein A and the 3 helix together, put it into E. coli and express it. And you can see that we can nicely express the protein in the soluble form with both 1 copy or 4 copy of protein A. It's the same here. And then we can nicely purify the protein. It's quite beautiful. So then we had the purified protein. So we want to test whether it can make the recombinant protein stay on the membrane. and then it can capture the antibody to develop the lateral flow test. So for the first one, to immobilize the protein, what we did, we just spotting the protein onto the membrane, let them dry overnight, and then we do the simple lateral flow test using different solutions like water, PBS or BBST, and then we visualize the diffusion of protein by Ponceau. And what we should keep in mind that if protein binds strongly to the membrane, it will give the really round shape. Otherwise, it will diffuse along with the flow. So the more or the longer diffusion length, the less absorption capacity of the protein. So if you can see here in the upper left, the protein A, one copy along. And you can see even in the case of no lateral flow, the protein spot diffuse really big circle. And after lateral flow test with different kind of solutions, they almost disappear from the membrane. In the stark contrast, the protein A, when it fills with 3 helix, you can see that even after the lateral flow, the protein remains the round shape and the round spot. So it indicates it's really stable. It's not washed away by the flow. And the same case for the protein A with 4 copies. So we can nicely see that after fusion the protein A with 3 helix protein, it can nicely retain the protein on the membrane and without stripping away by the lateral flow. And next, what we did, we test whether it can capture the antibodies. So with that, we immobilize protein on the membrane and then do the lateral flow test. And in this case, in the solution, we put gold nanoparticle conjugate with antibodies, and then we visualize by naked eye. And you can see that when we immobilize the protein with 3 helix, you can see it has a really clear set band. And for the control one, you cannot see it. So it would mean that the protein, when it's filled with the 3 helix, it can nicely retain on the membrane. It also captured the antibodies, and it gave us a really strong signal. And after that, we try a different kind of setup for the flow test, and the results are not showing here. So with that concept in mind, yes, with that concept in mind, we have to go further. So we either develop the fusion protein with protein A or sammavidin, which means that we can either bind to the antibody or any biochelated probe, and then we fill with different kind of material binding protein. So in this case, we develop for the binding for gold, graphene oxide, silica, PMDS, yes, and so titanium, etc. And with the same concept, we want to see that whether the antibody immobilize on the material increase and prevent the protein clumping. And we also have a collaboration with a professor from Taiwan, from NCKU, for development a platform for detect the cancer. And it's also for develop the virus using surface and Raman scattering. So the last slide of my talk, I will briefly introduce about the research topic of mine. So I'm based on the recombinant protein. So mostly we develop the biosensor, or we can use the M cell targeting for oral vaccine development. We also try to manipulate the microbiota for obesity prevention. And we also apply recombinant protein for the cosmetics. And lastly, we use biocompatible nanoparticle for drug delivery. So last but not least, I would like to thank the main funder, the Medical Delta Program Office and the Vietnam National University for sponsor this program, and thanks our group for this work, especially the girls behind me. This is almost her work. Thanks for your attention.
Okay. Thank you for your presentation. Any question? Because of a time constraint, we only can have one question. Anyone?
Yes, so I can take one question.
If there's no question, I would like to ask one question, because when I was doing my doctoral study at the University of Michigan, actually I'm working on using quantum dots and coated with protein A and antibody.
Yes.
Really similar to your approach.
Yeah.
Yeah, and I don't know. That's I use a magnetite nanoparticle, also quantum dots. It's kind of small, but yours is the surface. Would you give me a comment? Which one may be better for this kind of maybe high specificity sensing application? The surface one or a suspension, a particle one, which one will be easier to implement?
So it depends on the application. So in the case that your sample is nicely in solution, so it's easy to use nanoparticle, especially the magnetic one, because it's nicely can isolate the analyze, and later on you can apply directly to analyze. And in the case membranes, but the membrane, the best way to apply that they can apply in the remote area where they have nothing to do, just simply spot the analyze, and then so that's the reason why we have to develop the lateral process.
Okay, yes, that's true. Okay, thank you very much for your presentation. Thank you.
Thank you. If you have further questions, please email me.
Okay, we'll go to the next one. The second presenter actually is she's from Professor Zhenru Liang's lab, and he's going to present. I think she's Miss Shi Yan Tai Hong Dang. I don't know. Okay. The topic is degradation of atrazine by first iron activated persulfate processes in aqueous and soil slurry phases. Okay, I'll give it a time to Miss Dong.
Thank you so much. Good afternoon, Professor and everyone. Today I would like to talk about my topic, degradation of atrazine by ferrous ion activated persulfate process in aqueous phase. My presentation is divided 4 parts: introduction, material and methods, result and discussion, and finally conclusion. Now let's move to the first part, introduction. Atrazine is widely used the herbicide in the United States, Taiwan, and also in Vietnam. It's used in the crop crops, sugarcane crops, and the concentration of atrazine in groundwater has been frequently found to be higher than the maximum contaminant level 3 micrograms per liter for drinking water set up by Environmental Protection Agency. And some recent study on a frog, atrazine can turn the male frog into the female, and it can affect insulin system in human and animal. So that's why I choose atrazine to the target contaminant to be studied in this research. On the right hand side, you can see the physical chemical properties of atrazine. It has a high solubility in the water, 33 milligram per liter, and the half-life in soil about 60 days, and in water 100 days. And the right hand side is the structure of atrazine. And I would like to introduce about Taguchi methods. Taguchi experimental design is obtained to useful information with fewer experiments. And the Taguchi orthogonal rate is expressed by L number B to C. It means L number is mean experiment times, and B is mean number of levels, and C the number of factors. So when we use the Taguchi method, we need to identify the factor and levels, and then design experiment and select the treatment efficiency and quality characteristics. And then next we conduct experiment, and finally we use the SN ratio and another software to analyze the data. And this is the object of my research. To investigate the atrazine degradation by activated bisulfite processing in aqueous phase, and investigate the effect of temperature, and finally investigate the potential degradation mechanism of atrazine based on the identified degradation by products of atrazine. And let's move to the second part, material methods. The first, I try to investigate effect of atrazine, ferrous ion, bisulfite, and initial pH. And the next, after determine the optimal condition, I do effect of temperature. And then in this research can implication for the field application in the soil. And the first, I identify the factor and levels. So you can see in this table, we have the 4 factor: atrazine, bisulfite, ferrous ion, and initial pH. Each factor we have 3 levels. And this I design experiment depends on the Taguchi orthogonal rate L9 3 to 4. So the total we have 9 experiments, and 4 factor, each factor we have 3 levels. So I design this experiment you can see in this table. And the next, with the 9 experiment, I do 9 control tests. And the first we select the treatment efficiency. So in here I fix the equation to calculate atrazine removal, with the C is mean concentration of atrazine after doing experiment, and C0 is mean initial concentration of atrazine. And because we have atrazine removal, the highest is better, so I calculate the SN ratio based on the larger is the best. And the next is experimental procedure. The first, I prepare the atrazine stock with the concentration 25 milligram per liter and checking during 24 hours. And also prepare the ferrous ion solution and bisulfite. Because in here I adjust initial pH at 3 level, 3, 7, and 10. And then I mix it in the 1 glass bottle at 20 degrees Celsius with different dose, and take the sample to analyze it. So in here, analytical methods, we have 6 parameters to analyze. The first atrazine I use the SPLCBD8, and the second pH ORB meter. For byproducts of atrazine I use GCMS, and bisulfite I use UV with spectrophotometer at 400 nanometer. And for ferrous ion and total ferrous ion, I use spectrophotometer at 560 nanometer. And finally, TOC analyzers. So now let's move to the most important part, results and discussion. This figure about atrazine degradation with 9 Taguchi experiment. So at atrazine degradation decrease so fast. Atrazine degradation increase so fast just in the initial phase, 2 minutes, and after 2 minutes is no obvious change, because when the sulfate react with the ferrous ion to generate sulfate radical, and sulfate radical as a strong oxidant with the redox potential high from 2.5 to 3.1. So that's why hydrogen degradation can increase so fast at 2 minutes. And then efficiency gets 100% after 3 hours in experiment 3 and higher than 90% in the experiment 1 and experiment 9. And the next, because the hydrogen degradation increased so fast at 2 minutes, so the concentration of ferrous ion, total ferrous and sulfate also decreased so fast at 2 minutes. And here the result about pH and ORB, because I do experiment at pH 3, 7, and 10 on experiment. And after doing experiment, the pH decreased at nearly 3 because the sulfate dissolved in water to generate hydrogen sulfate, and hydrogen sulfate to generate hydrogen ion. So that's why the pH is acidic. And in here, because hydrogen is an organic compound, so I try to measure the total organic carbon TOC, and the TOC removal is response to hydrogen removal. And in here, the total result about hydrogen removal of 9 experiments, you can see in this table. And I changed to SN ratio to calculate the contribution of 4 factors. And here, so the most efficiency in experiment 3, 100%. But we need to calculate the contribution of each factor depends on the SN ratio and mean of means. So because we calculate using the equation larger is better, so the value in here larger is better. So we can determine the optimal condition at the hydrogen concentration 3 milligram per liter, and sulfate 10 millimole, and ferrous ion 1 millimole at pH 3. And in here, I calculate the contribution of 4 factors based on the degree of freedom, sum of square, and mean square. So this table demonstrates the sulfate concentration is the most significant in this process. And in this process, and the second is the pH, and the third is hydrogen concentration, and finally is ferrous ion. So I also do the conform experiment to compare with the predict optimal value. So it's the same result, get 100%. And in here, after determining the optimal condition for 4 factors, and I continue determine the effect of temperature at 3, 10, 20, and 40 degrees Celsius. So the result in here at 10 degrees Celsius, the hydrogen degradation just get higher than 70%. But when we increase the temperature at 20 degrees Celsius, the hydrogen degradation get 88.4%. And then when we increase the temperature at 40 degrees Celsius at 2 minutes, the degradation of hydrogen get 100%. So demonstrate that the temperature can affect in the ferrous ion activated sulfide process. So this is my conclusion. In this experiment, hydrogen can degrade it by ferrous ion activated sulfide oxidation processing by Taguchi methods, and the optimal operational condition at the sulfate 10 millimole and pH 3, and hydrogen concentration 5 milligram per liter, and ferrous ion 1 millimole within 3 hours at 20 degrees Celsius. And in this process, the sulfate contribution is the most significant. And in the future, I would like to apply this process in hydrogen contaminated soil. So that's all my presentation. Thank you for your attention.
Okay, any questions?
question.
Okay.
So I have two questions. So thank you very much for your presentation. I have two questions. The first question, could you please tell me how is the concentration of antacid in the environment? And why you, in your experiment, you choose the concentration of antacid is 5 milligram per liter? Why you choose that concentration?
Okay,
And,
thank you.
Yeah. And another question. I know that in your experiment, you just do the research on the antacid. You don't use the wastewater.
Yes.
Okay.
Okay. Thank you so much for your questions. The first question about why I choose atrazine, because atrazine is a herbicide. Right now, it's banned in.
My question is why you choose the concentration of antacid is 5 milligram per liter.
Okay, because the atrazine solubility in the water at 33 milligram per liter. So I do experiment at 3 level. The maximum is 20. Is make sure the atrazine can dissolve in the water, on dissolve in the water. So the maximum concentration is 20, and the medium concentration is 10, and the lower is 5. So that's why I choose 3 level: the higher, the medium, and the smaller. And the second question.
So, but how is the concentration of antacid in the environment? Because if the antacid in the environment lower than the 5 milligram per liter, so that means what is the purpose of your degradation of antacid? For example, in your study, you use the concentration of antacid is the 5 milligram per liter.
Yes.
But if in the environment, the concentration of antacid just below 5 milligram per liter, so how is the purpose of your study? Okay.
Yes, because in my study try to apply to treat atrazine. When I determine if you use so slow concentration of atrazine, so you a little difficult to analyze the atrazine by HPLC or GCMS. So I try to fix the concentration at 5. If after find the optimal condition, you can calculate the ratio of optimal for ferrous and bersulfate. If the concentration of atrazine in environment the lowest, so you can use the ratio of optimal condition to apply in it. You can calculate the concentration, and treatment is easy.
Okay, thank you.
Thank you so much for your question.
Okay. If there's no more question, we'll give a big applause to Sang Yong, right? Su Yan. Sun Yan. Okay. Very nice talk. Yeah. Okay. We have the next one from Vietnam is Dr. Tai Hong Lei. Can you hear me? Dr. Tai Hong Lei.
So, Hoàng, please turn on the micro. Turn on the mic.
有在这里，影像在这里，影像在这里，声音。Can you hear me, Professor Lei? The next one from Vietnam is Dr. Tai Hong Lei.
Yes.
Can you hear me? Oh, you can hear me. Okay.
Yes.
So Professor Lei will bring a talk. The topic is seasonal variations in water quality, antibiotic residues, antibiotic resistant genes in surface water along with the Saigon River. Okay, we'll give it time to Professor Lei. Professor Lei?
Yes.
The next one
from Vietnam is Dr. Ai Hong Lei.
Can you hear me? Can you hear me?
You can hear me. Okay. So Professor Lei will bring a talk. The topic is seasonal variations in water quality, antibiotic residues, antibiotic resistant genes in surface water along with the Saigon River. Okay, we'll give it a time to Professor Lei. Professor Lei?
Yes, yes.
The next one from Vietnam is Dr. Ai Hong Lei.
Can you hear me?
Can you hear me? You can hear me. Okay. So Professor Lei will bring a talk. The topic is seasonal variations in water quality.
Professor Lei, can you hear me?
Yes, yes.
Yeah, probably you have a YouTube on beside you. Is that right?
Yeah, that's right. That's right.
Yeah, probably turn it off.
Okay.
Okay, that's good. Okay, we can start.
Okay, so first of all, I would like to thank Dr. Susie and Dr. Hing for give me this opportunity to present. So today I would like to talk about one of my research in Vietnam. So the topic is seasonal variation in water quality, antibiotic resistant residue, and antibiotic resistant gene in the surface water in Saigon River.
Professor Lei?
Yes.
Yeah, would you please share your screen? We cannot see your screen.
Oh, really? Slide.
Okay, great.
Okay, yeah. So I would like to talk about antibiotic resistance because this is one of the hot topics nowadays, especially in Vietnam. So we have a lot of pandemic, we have a lot of infection disease, and if we also have the antibiotic resistance problem, so that will be the something very serious problem. So there are many scientists concerned that antibiotic resistance will be the next pandemic in the near future. So actually nowadays we have a lot of attention about coronavirus, right? But actually coronavirus or other infection disease, we will have the vaccine sooner or later. But we will not have any vaccine for antibiotic resistance, okay? And according to FAO chief, so the guy mentioned that antibiotic resistance will be the next pandemic because of several reasons. So I'm going to start. People, plant, and animal dying from the infection and cannot be treated even with the best antibiotic available nowadays. And the rates of antibiotic resistance increase the failure of treatment. And it is a global problem, and it's impact the people and spreading around the world. So with this reason, we can see this is already a pandemic. Okay. So this slide, I would like to show some statistic data about antibiotic resistance. So we can see that the number of people die because of antibiotic resistance in 2014 is about 700,000 people dead because of some reason related to antibiotic resistance and bacteria. And this is among top 5 causes for the human death in the world. And if we don't have any proper action, so the people estimate the number will raise up to 10 million people in 2050. And it will cost about $100 trillion to treat. So among a lot of the bacteria or virus or any pathogen cause the antibiotic resistance, so E. coli, Klebsiella, malaria, tuberculosis will be the biggest impact. So in my study, we want to focus on the antibiotic resistance in aquatic environment. So there are several reasons. In the aquatic environment like the lake, river, and the canal, the water body receive a lot of waste and wastewater and any waste from the human activity from environment. So we expect this is the ideal environment for antibiotic resistance develop. And the second reason is aquatic environment like the lake and the river easy to spread down in the environment, and it will be the great concern and can pose the risk to animal life in the ecosystem and also for the human health. So because of that, so my research area is focused on several topics. So we want to monitor the occurrence of antibiotic resistant residue, gene, and bacteria in the surface water. And we start doing research in Ho Chi Minh City. So we want to know more about what is the factor driving this antibiotic resistance. So we want to see both natural factor and the human factor as well. And eventually what we want to do is we want to combine all the data together and see what is the potential risk that with this label contamination it can cause for the public health. Okay, so I would like to show some of my study in Ho Chi Minh City. So this is the part of the research project in local in Ho Chi Minh City. So we want to see the antibiotic resistance level in the Saigon River. So as you can see in the map, this is the Saigon River and the boundary is Ho Chi Minh City. So the total site we collect is 11 sampling sites. So we collect 3 sites for represent for each human activity. The A represent for agriculture site, and L represent for less impact site. So we use that to control. So less impact site is the site that a little bit far away from the urbanized area on human activity. I for industry area and R for in the downtown, in the central Ho Chi Minh City. So we want to see what human activity played an important role in the concentration of antibiotic resistance in the Saigon River. So so this slide shows the physical parameter that we measure in different seasons. So we want to see in Ho Chi Minh City we have only 2 seasons, the dry season and wet season. So this is the tropical climate. So we want to see what difference between 2 seasons. And the data show that almost of the case we see that the pH, conductivity, salinity, and temperature is higher in the dry season is higher than in the rainy season, and purified and turbidity in the rainy season higher than dry season. So the data indicate that we may expect that in rainy season the river more contaminated with organic matter. Okay, and so maybe because of everyday rain in rainy season. So if we classify into the human activity, we can see that among 4 activities that we investigate, industrial and residential, so labeled with I and R, so have the significant higher than the less impact in agriculture side. So so this is a little bit so agriculture, we will know that agriculture still give the big impact on the environment, but in this case we see that a very similar level with less impact. So one of the reasons is we can explain that because the site that we collect an agriculture site is in the upstream. Agriculture activity in Ho Chi Minh City located in Củ Chi district upstream of Saigon River, and that is the first reason is far away from the first reason is the government try to organize as the and apply many high technology there to control the waste and wastewater release. And the second reason is the sample we take at a less impact area, also in the upstream river, so we can expect maybe there's because they close distance together, so maybe the concentration can distribute from the less impact, from the agriculture side to the less impact side, so make the level is not much different. Okay, so the nutrition concentration, we see that we test for phosphates, nitrate, and ammonium, and we see that it's high in the rainy season. So it is consistent with the data we show in the first slide. So we also found that the pollution of nutrition for the industrial and residential side compared with the less impact side and agriculture side. Okay, so heavy metal also measured in the sample. So we want to see the concentration of heavy metal in the Saigon River too, because there's several studies show that heavy metal have some antimicrobial activity too. So some bacteria resistant to have in the sample, if there is the heavy metal there, we can find some antibiotic resistant bacteria there. So the mechanism resistant to heavy metal is expected to similar with the mechanism to resistant to antibiotic. So that's why we want to measure the level of heavy metal in the sample. But we found that the concentration is not high. So as you can see, that almost the case is within the national limit. And if we compare with between two seasons, so it's a little bit higher in the dry season. So we also try to do the principal component analysis to we want to put on all the parameters together to see how close the relationship between the parameter and the sampling side. So we can see that the principal component one, the horizontal axis, is explained for more than 28% of the total variance. It's well correlated with pH, temperature, BD5, copper, nickel, and zinc. So and we will see that this, so on that side, we see that a lot of sampling side from industry and residential. So we can expect that the sample water from the industrial side, residential side is contaminated with heavy metal and some organic matter. So antibiotic chemical also measured in the sample, but we cannot detect. So we try to measure 5 different types of antibiotics, but we cannot detect. So all the cases under the method detection limit. So we use the methods of MC-MSMS. So there are many factors can affect on the phase of the antibiotic in the river water under the environment condition. So we only detect some sample with the antibiotic sulfa, methoxazole, and trimethoprim. This is 2 antibiotics that are very stable in the environment condition, so we can detect in some sample. But for the other case like beta-lactam, amikacin, cefixime, or ciprofloxacin, we cannot detect in any sample. So antibiotic resistant gene. Antibiotic resistant gene is the DNA that encode for the ability that the bacteria can resist to antibiotic. Okay, so nowadays the people consider that the gene is the emergent contaminant. The reason is because that gene can transfer from one bacteria to the other bacteria. So it may transfer the resistant phenomenon, antibiotic resistance in the microbial community. So we try to detect the gene for we will try to select some typical gene. So one antibiotic, there are many genes can involve in the antibiotic resistance mechanism. So we try to pick some typical gene, and we see that AAC6, platam, and intercon class 1 and SUN1 is the 4 gene that show the most prevalent in the sample compared with the other gene. And the common phenomenon that is also we found that high prevalence of the AIG gene in the industrial side and residual side compared with the other side. So, okay. So the relative abundance of antibiotic resistant gene we determine by device the number of gene copy per the total gene copy of 16S ribosomal RNA. So 16S ribosomal RNA is the gene that represents for a total bacteria. So we want to see the antibiotic resistant ratio, and we see that if we calculate that ratio is higher in the dry season compared with the wet season for almost a K. Okay, so if we try to put on to see the relationship between AIG with the sampling size and other physical parameter, so we can see that the principal component 1 is explained for all the AIG together with the organic matter and harmony. Okay, so again, this is consistent with the previous data to show that the sample at the residential and industry are more contaminated with the nutrition, more contaminated with the organic matter, and also high abundance of antibiotic resistance too. Okay, so and also heavy metal, we also find a similar pattern. Okay, so let me summarize this research. So what we found in this study is that turbidity, BUD5, phosphate, ammonium are higher in the rainy season, but temperature, conductivity, DO, and some heavy metal are detected high in dry season. So the level of heavy metal is lower than the national limit for the surface water. And the antibiotic residue is below the detection limit, so we cannot detect in any sample. The level of the gene, antibiotic resistant gene, are higher in the industry and residential site, about from 1 to 3 order of magnitude higher than in the less impacted area. Okay, so in the final conclusion is in Ho Chi Minh City. So in this industrial and the residential activity in Ho Chi Minh City is playing more important impact to the Saigon River compared with the agriculture or the other activity. Okay, for this research, I would like to thank all the collaborators and funding support from NAPOSTEC and Vietnam National University in Ho Chi Minh City. So thank you for your listening. And if you have any questions,
thank you. Any questions? If there's here.
Hello. Hello, Professor. Thank you for your presentation. My name is Simon, a student of this department. I have 3 questions. I'm not too sure if the questions might be quite related to what you've just presented. But my first question is, are there any means of reducing the resistant bacterial load in wastewater?
So, sorry, you mean that any treatment of wastewater in Vietnam?
What I mean is, are there any methods that can be used to reduce the load of bacterial load in the wastewater?
Okay, okay. So can I answer now?
Yes.
Okay, so Like some previous presentation before, you know that in Ho Chi Minh City, the situation is we cannot treat all the wastewater. So so far only about 40 to 50% of the wastewater is treated before it's released to environment. So this maybe is of concern. That's the untreated wastewater contain a lot of bacteria, a lot of pathogen that can, and a lot of antibiotic resistant bacteria there, and it may spreading in the environment. And the second reason is so far that even the treated water is cannot completely remove the antibiotic resistant gene and antibiotic residue in the treated water. So there are many studies, not only in Vietnam, but there are many studies in the other country that they found that antibiotic residue and gene in the treated water, even after several steps of treatment. So the gene can be considered as the emergent contaminant. It can transfer to the other bacteria and it can spread the resistance.
Okay, thank you for your answer. My second question is, are there any environmental damage mediated by antibiotics in water environment?
I think this is a good question. So antibiotic residue, if we do not remove it completely, so when it released to the surface water, so the antibiotic resistance can be served as a selective agent. So where there is the selective agent, so the bacteria will try to evolve, try to overcome, try to switch on some mechanism inside to become the resistant bacteria. So if we if environment there's the antibiotic there, so the bacteria will develop the mechanism to resistant to that antibiotic, and one of the mechanism is the gene. Okay, so again, so the even very small concentration of antibiotic in environment, it can pressure, it can stimulate the development of antibiotic resistance in the community.
Okay, my last question is there any mean of tracking source of antibiotic resistance organism in water?
Because the situation in Vietnam, we don't have any data. We don't know if how contaminated of antibiotic residue or gene or bacteria in the surface water. So we don't know. So if we don't know, if we don't have any information, so we don't know what to do, right? We need the information. We need where got contamination, what is the source, and we will, when we have the baseline information, we will develop the strategy to control and eliminate the problem. Okay. Okay, thank you.
Okay, because of time constraints, so we thank Professor Lei for his brilliant presentation. Thank you.
Thank you very much.
So, okay, now is the last presentation. I will make it short. Okay. Okay. I'm the last presenter, and the topic is the in situ phase inversion emulsification and microbiome reengineering for efficient bioremediation. My name is Suji Chang. I'm the chair of the Department of Environmental Engineering at the NCHU. Okay. Okay, they outline the needs and the technology development and the applications and the future work. And the needs is that for the river sediments, originally we work on the river sediments. And then we found that it's so efficient. So we try to use this technology to other environmental metrics. So this is just why the sediment is important, because it's a very short cycle time. It could come back to the human through the food chain. So if it's heavily contaminated, it will be really bad for human health. Okay, there are a variety of pollutants in sediment, like POPs, persistent organic pollutants, are one of the hardest to treat because they have a high KOW, very low KH, very low water solubility. And the remediation technology has been developed for decades. That could be classified into physical, chemical, and bioremediation. And for bioremediation only, there are several ones like natural recovery, biostimulation, bioaugmentation. And now we are talking about microbiome re-engineering. It's a new one. Okay, so here are some examples for the different contaminants in the sediment. You can see for the benzopyrene, okay, and benzopyrene and the hexachlorobenzene, alkyl 1254 is a polychlorinated biphenyl, and then the PBDs. Okay, in the groundwater like a TCE, okay, like 1,2-DCA, like 1,1-DCE, and the vinyl chloride. And you can see the big difference is that the molecular weight is very different. And the low KLW for those in sediment are very high. For the vapor pressure, for those in sediment, really low. And for the water solubility, very low. Okay. And I will just go really quickly on applications like PCBs and HCB in sediments, and Linden and DDT in soil, and the TC in groundwater. And now we are testing it on diacids. Okay. The way it works is that first we have a unique emulsion system. You can change the phase from oil in water to water in oil emulsion because of the temperature elevation. So now we use the really hot emulsion to inject the emulsion into the bottom of the sediment. So now the hot emulsion is a water in oil emulsion. So then it will behave just like the percent organic pollutants. So it get really good contact with those contaminants. So we keep the temperature for like 30 minutes, and then we input like a full pore volume of cold water or nutrients, and then we put it back. Because of this in situ phase inversion emulsification operation, we can recover about 50% of the contaminants. And then we wait for the bioremediation to work. And microbes in the sediment will use those residual oil phase to degrade those chlorinated contaminants. Okay, so here is the phase inversion emulsification. It's been done 20 years ago. And then the desorption, because high temperature, the desorption is faster, and they will have a little impact on the KLW. So actually the KLW will be lower because the temperature rise. Okay, but it's okay. It could be more bioavailable. So there will heat selection effect on the microorganisms. So actually we thought it could be bad for our microorganisms because we elevate the temperature to like 95 degrees in Celsius and could kill some of the microorganisms. But we found they probably can select more at the bottom of the sediment, select the hydrogen producing bacteria, and at the top, the dechlorinator can still live. So we published this in 4 SCI journal papers. The last one is published yesterday. Okay. It's a microbiome re-engineering by heat selection for rapid biodegradation of trichloroethene with minimal vinyl chloride formation. Okay, and we got 2 patents in Taiwan. Just how we did it. Okay, just use those instruments and devices, and we use similar thing. Okay, just the Taguchi method. Okay, for the PCBs and HCB. Okay, we got pretty good results for a batch test. We can achieve for the HCB could be like more than 90% removal, but for the PCB is not so good. Okay, we can also compare that for the half-life and also for the rate constants, and we found that HCB is much faster than the PCB. Okay, so we also did a pilot study. We built some construction in the river, okay? And we did the in situ pilot study in the river. Okay, so we come up with, because in the sediment, in the sediment, there is weathered PCBs and HCB. So we use the sediment, and also we add the fresh PCB and HCB into the sediment, for we can put into 2 groups. One group for the weathered contaminant, the other group for freshly added contaminants. Okay, so here is the ISP recovery. So it's not so good, you know, in the real world. Okay, the in situ phase inversion emulsification cannot achieve that kind of recovery like we did in lab. Okay, then we wait for like 70 days for the biological reduction of declination. Okay, and for the weather, you can see that, okay, it decreased a lot. Some of them just 100%, about 96% being degraded. For the HCB, you can see that for the weather one, it's really could achieve like a 100% degradation. So here is the total removal for the weathered at the upper panels. You can see that for the different, this is first is blank, and then is natural recovery, then is biostimulation and bioaugmentation. So the natural recovery, we just do the recovery and didn't do anything else. For the biostimulation, we do the ESP recovery, and then we add some nutrient. For the bioaugmentation, we also add some acclimated microorganisms. Okay, so you can see that for the PCBs, the weathered PCB, the total removal can achieve higher than 98%. And for the weathered hexachlorobenzene, you can achieve 100% removal in 70 days. Okay, here's just the NGS next generation sequencing of all the microbes, okay, in the sediments. Okay, so we can find some interesting microorganisms. So here is the linden and the DDT application in soils. Okay, this is the batch study. Also, we also did the current study to do the recovery, and it's not so good, but KLW value is kind of lower than PCBs and HCB. And we also did the same bus study, and now the result is pretty good. Okay, you can see that for the DDT, okay, for the DDT, you can achieve like a 99.7% removal, okay, in 40 days, 42 days, and the linden is not so good, okay, but it's also higher than 90% removal. And this is the NGS analysis. We like to know the microbial interaction, okay, to see that if there is a certain pattern there. Okay, here is for the real soil from the organic farm. We come up with about 400 microorganisms. They have a good correlation with the removal. Okay, and here is the application in TCE in groundwater. So we found that probably the temperature did a lot of work on the biodegradation. So we tried 8 different conditions. Actually, it's 2 different period of time for the heating time, like 30 minutes and 60 minutes. And for the temperature, we tried 50, 65, 85, and 95. 90 and 90 are 80 and 90 degrees in Celsius. And we found that this is improvement of the rate constant. Okay, how many folds? So you can see that actually around the heating time, probably around like 40. You can see the blue plateau there. The temperature probably around 70 to 80 degrees Celsius. The improvement could be as high as 80 times faster. So actually the half-life, you can take a look at the half-life. Okay, it's not here. The half-life is as short as 1.5 hours. That's within 1 day, it can have 16 half-life. So if you times 1.5 by 16 times, it'll be more than 100 times. That means 100,000. Okay, 100,000. Okay, that's so you cannot detect it. So for 5 of the conditions, actually after 1 day, it's totally gone for the TCE. And we also did the maximum specific TCE degradation rate, and we compared with the KB1. Now the KB1 mixed culture has been sold to more than 1,600 sites in the world, and our rate constant actually is actually the maximum specific TCE degradation rate is more than 2 orders of magnitude higher than this commercial one. And it's also about 11 times higher than the diacrylate cationic. Is very famous. They have dechlorinating pure culture. Okay, so about the microbial interaction, we would like to take a look about those mechanisms. They have a good correlation with removal, and how about they interact with each other. So we can see that after we have done the clustering, there are two big clusters. One at the top, the other at the bottom. And within each major cluster, there are still two more subclusters, okay? And you can see that, you can just observe that on the first cluster, okay, first cluster here, okay? And the third cluster here. Have you found something interesting? This one and this one, they are totally opposite. Have you seen that? If it's red, it's green. The red is green. Okay, for the red one means if I grow well, you grow well. For the green one is that if I grow well, you don't grow well. Okay, it's like a negative effect. So here is 1 to, from this top, you can see that there are 33 different microorganisms. But here we have a cluster, so it's still the 33, but it's a different orders, okay? So you can see that they are big group. They are big group. They are fighting each other. They are kind of fighting each other. Okay, for the very bottom cluster, you can see that very bottom cluster. Okay, they are, you can see the, okay, here. For the bottom clusters, you can see here, right? It's almost like red, it's no green. So that means this group of microorganisms, they do benefit others. Almost to all different microbes. They are doing good for others. They are helping others to fight against each. They are helping the first cluster, they are helping the third cluster, but they're helping them to fight against each other. Okay, and the second cluster, the second tiniest cluster, the second tiny cluster is almost opposite to the fourth cluster. The second cluster only have 2 microorganisms, but they are almost all of the interaction is green. So that means if they grow well, not good for others. They will kill others, some kind of land. Okay. 他们长得好的话，就对其他人不好。Okay. Okay. So next one. Okay, this we have a preliminary results on dioxin and the furans. So we just take a look at this 2 curves. Okay, this one, the very high concentration one from here, and within like 35 days drop to 0. And this one, this open rhombus, you can see that also drop to 0. Who are they? The first one, this one is OCDD. Okay, that's octachlorine dioxin. Okay, and this open rhombus is chlorine dioxin furan. It's they're fully chlorinated. So the fully chlorinated, they can be degraded down to 0. Okay, so that's pretty good. Okay, and this is now we are talking about this microbiome reengineering. It's a new field. New technology. Originally, we have a multi-natural attenuation, we have a biostimulation, we have augmentation. Now we invented a new one, microbiome reengineering. So it's a very different from those technology before. Okay, there's a comparison down there. Okay, and there's the future work. First, we'll finish the study of MBRE on dioxin. There's a 2-year project, and the identification of rapid TC degrader and the novel function of genes, enzymes, and the pathways. And there's a 1-year project now is going on. The magnetic nanosilica platelet for eutrophication control. There's a 1-year Unicode project with KPI to establish a startup company. Okay, and the microbial interaction to enhance the contaminant biodegradation. And then continuing the research on novel biodegrading enhancers, now it's commercialized. And we'll continue on the research on TC biodegradation without VC accumulation. Okay, thank you very much. Any questions? Okay, if there's no more questions, Professor Hin?
So I have one question.
Okay.
Thank you very much for your very beautiful presentation for me. So I heard that with the biome re-engineering, you can treatment the dioxin. How is the, have you ever been applied to treatment dioxin in the soil in Taiwan? Because in Vietnam, we have the problem with dioxin in the soil. So with this technique, we can treatment the dioxin in the soil or not?
I only have done the batch experiment in the lab. Okay, and I'm using really contaminated sediment from a sea lagoon. Just that kind of a pond is the seawater inside, and the sediment underneath is totally degraded. And OCDD and OCDF is, I remember, is like 10,000, higher than 10,000 ppt. So it's really contaminated, and we use that as the source for us to start the experiment as the contaminant, because now it's really hard to buy dioxin anywhere. Okay, so we use the real world contaminated sediment, start from there, and I think the results is pretty encouraging.
Okay. So I think in the near future you can test with the dioxin in Vietnam. And another question, how about with this? Have you ever tested with the B-fast substance? That means perfluorinated substance. B-fast.
B-fast?
Yes. That means the polyfluoroalkyl substance.
I cannot get. You are talking about chemical contaminants?
Yes.
What is that?
That means with this
PFAS. PFOS.
Yes.
Oh yeah. I would like to try it, but I think the analysis is so expensive.
Because
yeah, I don't have the instrument yet.
Yeah,
probably I have to try to find someone who can analyze that for me.
In my laboratory, we can analyze the B-fast and B-force.
Oh, really?
Yes.
Oh, really? Okay. Yeah, then we can collaborate.
Yeah.
Okay.
And so now I'm thinking about the methods to treatment the B-fast and BFOA in Vietnam. In the West Coast. Okay.
Yeah, now they are really hot.
Yeah, so it's very nice methods we can apply to you in Vietnam.
Okay. Before the end of the webinar, we would like to thank you all the presenters from the Vietnam
have
side.
One question?
Yes. Your question?
Sorry, can I have one question?
Oh, okay. Yes, of course.
In your presentation, you find that some microorganisms that have very high expression. I just want to ask you, what is your next step if you want to, based on your result, what is your next step for the bioremediation, or you will try to do field culture, or how to apply this result to for the treatment of the contaminant?
Okay, I have one slide I will prepare for this question. Okay. 3之4最后面这个倒数第二个下一个 Okay, sorry for that. It's still in Chinese, but I will explain to you what we are going to do right now. The first, the circle down at the bottom is what we can do in our lab. Now I have a project working on the microbiome re-engineering. We have a professor from biotechnology department. Okay, and he can do we only did next generation sequencing. He can, based on the 16S ribosomal RNA genes, to pull out the full genome information from the database and compare, just like what I showed you, the microbial interaction and what group they are really good, which group they are really good at degrading TCE, and which group is not good at that, and he can compare the genome of those microorganisms and try to find the real working functional genes. So then we will come up with primers to detect those functional genes. Okay, and then also because now we are generating 100 to 200 NGS data sets each year. So we also include a professor from information engineering. So he's good at artificial intelligence. So he will develop an algorithm for us to recognize the patterns, how those mechanisms are interacting, how they can survive, how they can capable of degrading, and maybe there's some other patterns, some other reasons we don't know, but the artificial intelligence could help us to solve that. So now we have 3 professors working on this, and later we would like to come up with a new degrading strains, new functional genes, new enzyme, new pathways, new interaction patterns, some unknown effects. Then probably we'll have a new research questions like mixed culture, pure culture, enhancement, screening methods, other contaminants, other environmental matrices, culture from different locations. And later we will come up with, actually we will apply for a research center proposal to the Ministry of Science and Technology. With that to get more electro properties. Okay, and we probably will establish an intelligent bioremediation center in Taiwan. That's our ultimate goal. Yeah. Okay.
Okay.
Any further questions? Professor Lei? So, okay. Since we don't have any further question, thank you very much for participating in this webinar. A special thank Professor Hing for all your coordination and all your help. Without that, we cannot have this webinar. Thank you so much. Thank you so much. Okay, now.
So
yes.
thank you very much.
Okay, so we hope that in the future we may have some new collaboration between these two colleges, 2 different departments. Okay, and also we hope some of your students can apply for our master programs, and the deadline actually is in March 31. So that's next week. Okay, they can still apply. It's online. You can apply that online.
Oh.
Okay. Yes.
How
If they are
about the
interested. Yes.
So this the 31st mark is for the which semester? The deadline for which semester? For the October?
Yes. Yeah. Also, if the COVID-19 pandemic is going down, is getting better, probably I will invite you to visit us. Okay.
Yeah, thank you.
Again, yeah, in the next semester. Yes.
Yeah.
We will see how it goes.
Okay, thank you so much.
Okay.
Yeah.
So we'll say.
Thank you very much. Bye bye and hope
okay,
see
bye.
See you. Okay, bye bye.
Okay, see you. See you.
Thank you so much.
Okay, see you. 好，谢谢。 Lei, we haven't finished. Can you hear me? We have finished. Can you hear me? 他的声音没有出来啊。You didn't turn on your speaker, your mic, so I cannot hear you. Nice, nice. How do I say that? 舒言 huh? Swing. Oh, that's the one sound. Oh, swing. Okay, one sound. Okay. One swing. Okay. I learned the